Welcome to NWA Connie Corso's podcast, where we talk all things dogs.
What's going on, everybody? We're back. We're doing this as a simulcast with Brother Lee Robson, and it's going to be a great show. How you doing, Lee?
I'm doing good. How about yourself?
Oh man, it's been a heck of a day, but we in it to win it.
Yeah, there you go.
Yes, sir. Yes, sir. So
There you go.
we was gonna cover dog genetics and kind of break it down.
Yeah,
like how we can.
I think I lost you. Can you hear me?
I'm still here, man.
I don't know what happened. Am I? Oh wait, I do. I see.
Okay.
I see. All right. I somehow clicked into a different tab. I didn't know if I'd do a swipe up on this stuff. Let me get back to the proper tab.
Okay. What's up, everybody?
There we go. There we go. I'm back. All right.
Yeah.
Cool.
What's up, Chad? You got some heavy hitters. You brought some heavy hitters out.
I did.
I see All World Doberman, the Connie Corso enthusiast, Vaughn, Gunter, Haas. God, there's a lot of them in here. I see them. Okay. Let's do it to it, Lee.
Yeah.
What you got for us?
Yeah. How many people we got in here? I can't see it.
We got 33 so far, but you know it's finna
That's
fill
pretty
up.
good for just getting just starting.
Yeah.
That's pretty good.
Yeah, that's really good. Just start.
Yeah. Well, I appreciate y'all tuning in.
Yeah.
What's the topic for the day? I think we both know, but I'm gonna let you you do the guide on the questions, and if I can answer something, or maybe I'll ask you a question, and you can hit it up.
Okay, bet it up. So we wanted to get in talking about the basic genetics of dogs and understanding the basic genetics of dogs. A lot of us don't understand the terminology when the words get a little bit.
Sure.
And a lot of people just don't understand. You know what I mean?
Absolutely.
Yeah.
You know, and I think understanding genetics really is important, but I would not make it so much of a topic that you stress about. And the
Right.
reason why I say that is because natural selection and artificial selection, understanding proper selecting, making sure you're dealing with the right dogs, is going to get you 10 times further than understanding a little bit about genetics, because genetics matters. And there have been times that I've even used what's called the Hardy-Weinberg equilibrium equation. I've even used that in my own population, but it's something I do rarely, like maybe once every 5 years or something. When you're looking for the frequency of a trait in a population, the most important thing a person can do, if you have to decide, I need to learn about genetics, or I need to learn about how to select an animal, dealing with the good people, dealing with proper selection, those are going to be your top priorities of the most gains for the sweat equity that you put into your program. You're gonna go a lot further understanding these things. And then when you get to very specific refinement and you've already capped yourself on doing all you can with selection, that's when it's time to branch out into taking yourself to the next level to try to learn a little bit about this genetics. And it's easy to get overwhelmed with it if you're not familiar with these concepts and terms, because learning, I can learn your name, Joe, but if I had met 50 people in one day, I'm not going to learn your name.
Mm-hmm.
And so, it's kind of the same thing with genetics. I have to meet a little bit at a time, pace yourself, but I do have a lot of experience teaching biology and genetics. And because of that experience, I found some analogies that work really well to help people understand some basics, and not only understand them, but really put them into layman's terms on what these things actually mean.
Right.
Okay, because you can get a definition, but if the definition has words in it that you don't know, then the definition's pointless as well.
Exactly.
So but let's define what is genetics anyway. Genetics is the scientific study of the genes or codes that imprint and tell your body how to grow, develop, act, everything that you do that's outside of your free will. And some people even believe free will. I don't. I believe we have free will, but some people believe you don't have free will, that it's all programmed and you're just doing everything that um, your genetics tell you
Yeah.
to do. For example,
Right.
but I believe in free will. If you said raise your hand, one, right, left or right or left,
Yeah.
I believe that's a choice. But some people believe it's all biological and chemical, and
Yeah.
But regardless of that, outside of free will, which we do have, there's still a genetic code that operates things that we don't even pay attention to, like our blood flowing through our body. Our heart is programmed to do what it does. Our respiratory system is programmed to do what it does. And these programs are in our DNA that direct our growth, they direct our some of our preferences, they direct our hormone levels, they direct our behavior. And so that's what DNA is. It's a genetic or chemical language that biology is able to understand. So you following me so far?
Oh yeah. Oh yeah. The
Yeah,
main thing you said, I wanted to go back at the top of the clock, is you were stressing that before you get into all this stuff we talk about, the most important thing is selection. You know.
absolutely.
Yeah.
If you can only learn a couple of things, most important thing is bump your elbows with the right people. That's critical. Next, learn animal behavior. What does a behavior mean? There's a certain YouTuber out there that we laugh at a little bit from time to time, that he he was trained over a phone call but never worked with a professional.
Yeah.
And because of that, he already has a glass that's completely full. If you look at my mug here, this is a mug that my father gave me when I was a kid. It's full. There's no room for any more.
Yeah.
And when you already know everything, you don't have room for knowledge. And man, let's be honest, there's a lot of stuff out there that we don't know. No
Yeah.
matter how smart you are, if you
Right.
think your cup is full, you're a fool,
Yeah. Yeah.
because there's so much out there that we don't know. In fact, a wise man knows that he's a fool. A wise
Right.
man knows that the amount of knowledge that he has is nothing. You
Nothing.
know,
Right.
yeah. People laugh. That same YouTuber laughs because I believe in a creator, and he thinks it's ridiculous that a scientist can believe in God. But I think it's ridiculous that a scientist can believe a rock turned into a human being. So we're all entitled to our own opinions, but at the end of the day, we should pursue truth. We shouldn't try to win an argument. Trying to win an argument is when pride gets in the way,
Mhm.
and we need to set the pride aside and pursue the truth. And when you're dealing with people that are interested in pursuing truth, then you can sit at the table and have somebody on the other side that totally disagrees with you, because you're two humble men seeking the truth. And you
That's
can have
right.
a legitimate conversation. And those are the type of people that I like to converse with. I'm not interested in talking to people whose glass is already full and they're going to try to impose their will on mine and don't listen to anything I have to say. Because believe me, there's a whole lot that we can discuss on many topics where you can intelligently present two
Mhm.
opposing views.
Exactly.
And not only that, but sometimes the intelligence level could be elementary intelligence that seems like solid foundation, but when you get a better understanding, it may not be. Now, I have a friend, and I don't know if he's in this video. He's or watching. He watches a lot of our videos. He's a plumber for a living, but I have noticed something, and he can correct me if I'm wrong. But let's make a quick analogy here. Let's say you have a drain that's clogged, and you go to the store and you buy liquid Drano. You have one bottle that says clogged drains, clears it out for fully clogged drains. You got another one that says for partially clogged drains. Which one do you think is stronger? Which
Oh,
one do you think?
Jackson.
Yeah. Which one do you think stronger?
The one that's good with for the partial drain.
Yeah, most people would think the one that's for the fully clogged drain is going to be
Right.
stronger. But
Right.
why would it be? It's going to sit there and it has long time to work because the drain is
Exactly.
clogged. It can't flow through.
Right.
So it's got a long time to work. Now, maybe I'm wrong on this, but I know that I've tried to use that Drano that's for fully clogged drains,
It don't work.
and it doesn't work. But if you get the
Yeah.
stuff for partially clogged drains, it's
Uh-huh.
got to be stronger because it runs right through. So it has a very limited amount of time to work. But your
Exactly.
average person would probably think the one for a fully clogged drain is going to be stronger. But if you
Mhm.
think about it and you understand how it works, when I pour it in, it's going to run through. The partially clogged drain doesn't have much time to work, so it's got to be stronger. Now, I may be wrong on that, but that's what I've kind of seen. I'm not a plumber, but
Right.
but that's what I've kind of seen in genetics and animal behavior and protection work. I see a lot of people that get a small little dose of the topic and then they're speaking on these topics without really understanding them. And it's not good for the community because if you don't know, then we have two ears and one mouth,
Mhm.
and none of us know everything. So
That's
I
right.
want to ask questions for the people that know what I don't know, or people that can do what I cannot do. I want people to explain to me what I cannot do or what I do not know. But if
Right.
I do know something, um, then I generally speak with confidence on it. And sometimes people think that I know everything. Or I think I know everything because I speak with confidence, and that's because I say things one of three ways. I think, I believe, or I. Or, well, I say. Let me start over. I know this. I think or believe this, or I'm guessing.
Mhm.
And sometimes I say I don't know. So that's a fourth way. And so it's not hard to always be right if you're honest and say I know this, I think this, because whether you're wrong, you still thought it. That would be true. It doesn't
Mhm.
mean you're right, but you're leaving room for disagreement by saying, "I'm not sure. I think this is the case, but I'm not sure." And when people come out and they say this is the way it is with bold confidence, but they're wrong, that misleads people. And people have a desire to pursue truth. And so it's important that we speak on what we know and we keep our mouths closed on when we don't know something.
That's true.
So, on the field of genetics, I'm glad that you invited me to discuss this topic. This is an area that I've spent um, decades of my life
Right.
studying. And so I still don't know all of it, right? Because I
Mhm.
can't look at a dog next to me and see its trait. I can see the traits, but I can't, some of the traits. There's a lot of
Mhm.
traits I can't see. I can see only the express. There's, a lot of people think phenotype means the trait you can see. Actually, that's not what the word phenotype means. It
Okay.
means it means the trait that is expressed. And there are traits that we can see expressed, but then there's other traits that we cannot see if they're being expressed or not unless we do a test like a hormonal profile. Then we
Right.
can see it, but we're not going to see it with our eyeball. We have to see it with a quantitative measurement on blood samples or something like that. So there are a phenotype just means it's the trait that is expressed. But we'll get into these terms here whenever you're ready for me to break it down in a very simple way where people can leave this video and say, you know what, I have seen a lot of genetic videos, but today I kind of got a little better understanding of what these words actually mean.
Yeah. So that's what I want to ask you. Um, and this is on common misconceptions. What are some of the most fundamental terms in genetics that everyone should know, and what do you commonly see and get confused as far as misconceptions?
um, well, and that misconceptions, are you talking about to my video on misconceptions and deceptions?
Well, yeah, that too. I saw that one, but just
Okay.
misconceptions in
Because I
the
had a video about misconceptions and deceptions, but that was
right.
about our YouTube buddy that was making misspoken statements. But
I
in
got
terms
I
of
got a couple stalkers too.
yeah, yeah, I probably use some of these people must be very lonely or have no life. I don't see how they can
It'd be
take time
nuts,
to be
brother.
obsessed with
I'm
others,
telling you.
but and then they blame you when you respond to it, and like you're
Mhm.
attacking them, and I'm like, look, I wouldn't even know who you were.
Man, I think I got more threats than Donald Trump this year. Just hey,
You,
about what somebody said on the show. Like, what?
do you still have all your ear though?
Oh yeah, yeah, yeah. I still got those. Yeah, they really they ain't really about that life. I'll just put it there.
Yeah, I know. I'm kidding.
Yeah,
I'm kidding. I'm just being humorous.
yeah.
So with we do have a genetics video coming out soon that's going to talk about some equations that are used by some of the people in the canine world on genetics,
Mhm.
and that's going to be a pretty good video, I think, pretty soon. And I should have had it done 2 weeks ago, but life, I mean, I got 30 dogs in a family and 9 acres of property and a website to maintain and dogs to attend to. But so in family, my sister just found out she has breast cancer. My wife just got over that. So,
Oh man.
yeah, so there's always something going on, you know, and I'll get to that video when I can. But we're gonna go ahead and knock out some basic stuff that tonight that I'm confident that people will leave and say, hey, I learned something today. So do you mind if I do a quick screen share, or do you want me to? I didn't really get a misconception per se that we wanted to discuss right now, but I've seen, for example, here's one. I know one guy that talks about genetics all the time in some of these Facebook groups on some of the pit bull forums. And one time he posted that a Punnett square represented 4 generations and that each square represented a generation. I'm like, that has nothing to do with what a Punnett square is. But, you know, people just want to sound smart, and they know that 99% of their audience doesn't know anything about genetics. So if they say the word genetics, they think, oh, this guy's an expert on genetics because he said the word genetics. And I'm like, he doesn't even know what a Punnett square is. A Punnett square is supposed to show you it doesn't even show 2 generations. Some people think it shows the parents and the offspring. No, it doesn't. It shows the parents and the gametes that they can produce for the possible combinations of offspring. It doesn't even that doesn't even that doesn't even mean that's what you're going to get. It just means what you could get. Like if I show you a quarter and heads and a tails, and I say we have a 50-50 on a heads or tails, when I actually go to flip it, you can never get both heads and tails. You get one or the other. Yeah. So it's just a probability. The probability is 50-50, but in actuality, it ain't 50-50. If you only flip it one time, you have 100% of one and 0 of the other.
Exactly. Yeah.
So we'll discuss that. But let me go ahead and open my tab and do a share screen. I can't even find that tab, but if I do share screen, it should be right there. No, it's not. Okay, I know how to find it. You told me to type in notepad. There it is.
You got it? Okay.
It's fixing to pop up here. I got to share screen.
All right.
Well, it's not. Oh, I got to click on window.
Salute chat. Hey, everybody.
All right. Is it sharing the screen or no?
Yes, sir. Let me put it up here. Here we go.
All right, cool. All right, so I'm going to call this genetic analogies or analogy. So what we're going to do is DNA is basically it's a code. Okay, what that means is DNA is a language. All right. And language is, in this case, it's recorded. So it's not just language, it's recorded language. And what that means is it's information that is passed from one, in this case, cell or organism, to another cell or organism for the purpose of providing information on how to grow, live, behave, etc. All right. And so the main word that I want to focus on here is language, because our viewers, your viewers, they know what a language is. We speak with language all the time, but in this case, it's not just language; it's recorded language. And so what I mean by that is it's written down. All right. So by referring to it written down, we're going to now think about a language that we are all familiar with. If you wanted to learn something, you might go to what's called a library, right? And you know what a library is. It's a collection of books, right?
Yes,
it's a whole bunch of books. Well, it's not just one book. It's not just one page of a book. It's all the books. And if you think about all the people or all the living things on the planet, or in this case, dogs, all the dogs within a family, that's going to create what's called the gene pool. So your library is like your gene pool. Okay. A single individual is going to have what's called a genome. Okay. So the gene pool is all the codes or all the books. And then the individual has one book, one complete set of information, and that's going to be called the genome. But this individual received that information from 2 parents. So since there is in two parents, I want you to think about that genome as kind of being. Are you familiar with in this case, here we have oops, I backed up. Let's see, individual. I should have wrote a book. So a single book is like an individual. All right. So this is the population. Whoops. So the library is a population of books. The gene pool is a population of organisms, right?
Okay.
A book is an individual book, and a genome is the genetic code within one individual. Okay. So it's one book or one person, right?
Gotcha.
All right. Next, underneath that, we have what's called a trait. All right. A trait is something that is expressed. It could be a behavior, it could be a physical. This is like in a book, this is going to be basically like a topic. Okay. So when you read a book, there's going to be a topic. Now, every trait or every topic in a book is going to have a location. Well, that location is going to be your page number, right? What page it's found on. And it might only not be your page. It might also include a sentence, the exact location. This is the location. Well, a trait's location is called a loci. Okay. So we're having three columns here. The topic in a book is and I need to go put topic here again. It's kind of redundant, but so a library is made of books. Books have topics, and topics are on pages. Individuals, or population, individual. I should say feature. Maybe that's what I should say.
Okay.
Feature, and then that's going to be your trait. And then you have a look. So you have Man, I need columns. I wonder if I should do this in Word. Let me see if I should do this in Word. Give me just a hair of a minute. And we got a long list of these things here. I'm going to make 3 columns and drop it down. This won't take but just a minute.
Okay.
I'm almost done. I'm almost done with it.
Everybody hit the like button, share it. Thanks, chat. Glad you're here.
All right, let's I got to come back to StreamYard and share a different tab.
Oh, okay, let me go grab that. You want me to remove this one that's on the screen?
I'm trying to. Here it is, right here. Now I got it. All right, so let me go to stop sharing, and we're going to go to present. I'm going to share a different tab. I think this will work. Window. Yes. All right. Can you see the screen here?
I got you.
All right. So we had library. We had book. We had the topic. We had the page or sentence.
Mm-hmm.
All right. Over here for genetics, this is for the language. And then this is for genetics. Here we have the gene pool. Then we have the genome. Then we have the trait. And then we have the loci. All right. Now, loci or the genome, let's go back to the genome. I should probably bump these down a little bit. I may have gotten a little ahead of myself. Cut. Paste. All right, so books, if you were to look at a large section of a book, you'll see it has what's called chapters, right? Mm-hmm. And in the individual, you have what's called chromosomes. So people have seen the word chromosomes, but a lot of people don't know what they are. So a chromosome is just like a section of your genome. It's like a chapter is a section of a book. Okay, so look at it right here. You have a page that discusses a topic that's found in a chapter of the book that's in the library. So as we're going up, we're getting bigger and bigger, right? Here we're doing the same thing. We have a loci, which is describes a trait, and you could say a trait, and in this case, it may even be like a gene. And then those genes are found on chromosomes, and then you have genomes, and then you have gene pool. So this is going to be the population. This is an individual. This is a section. This is the item being discussed, like I said, the feature, and this is the location of where it's found. All right. Does that make any sense?
That make a bunch of sense.
All right. So I think anybody should be able to basically understand if I say a loci, what we're talking about is not a trait. We're talking about where the trait is found. Okay. And if we're talking about a trait or a gene, the gene is like the genetics. The trait is basically the phenotype. So these two go together. It's like genotype and phenotype. And then you have chromosome, which is the section. Some traits are found on the sex chromosomes, but most of them are found on the autosomes. So think of like a sex chromosome as kind of like a very, very small section. Oh, the X chromosome is pretty big, but the Y chromosome is really small. There's hardly any genetics on a Y chromosome. There are genetics there, don't get me wrong, but most of the stuff is found on the X chromosome.
So what, before you go any further, the father, the male carries the XX and the female carries the XY?
Other way around. Well, it depends on if you're talking about chickens or if you're talking about birds or talking about mammals. For the mammals, for mammals like dogs and human beings, the females are XX, and then the males are XY.
Gotcha.
So let me show you that here real quick. So, yeah, okay. So we're gonna jump down here, and I'm gonna make a new table. So if I was to insert another table, this time we're gonna do a 6x6. Let me get the spacing out a little bit better.
Man, Lee, you good at this stuff, brother.
All right. So let me center this also. All right. So let's see. Well, I was going to try to center. Oh, wait, here it goes. Boom, boom. And all right. So, and I'm going to do one more thing here on this table. And then it'll look like a Punnett square. So let's see. Borders and styling. All right. All right. Well, we're not going to worry about that. All right. So this box here is not going to matter. So ignore this box. This is nothing. Okay. Blah, blah, blah. All right. Yeah. What we're going to, all right. Maybe I should change that. What we're going to do is we're going to list the parents. All right. So we're going to say the father is X and Y. All right. Let me make this font bigger. All right. Can you see that? So yes, that's sir. The father. And then here's the mother, X. Oops. X. So she has one X that she received from her mother and one X that she received from her father. How could she receive one from her father? Very simple. He has one. Okay. He also has a Y. So every man has both of these, right? Every woman has both of these. So when she is going through a stage of sexual reproduction called meiosis, she's only going to donate one of these two. And that was going to be our next term that I was going to discuss on our, I got it right here. So the next thing I was going to say is chromosomes have what's called pairs. Okay. And with the chromosomes, let me drop this down. Those pairs of chromosomes are called homologous chromosomes. We all know what the word homo means. It means the same. Mm-hmm. So it doesn't mean, though, the same traits. It doesn't mean the same genes. It just means the same topics, okay? So maybe I should write topics here, and over here I need to put item described. Item described. Is described DI or DE? It's
DES.
DE in it.
Yeah, DES.
All right,
CRIP.
I'm good at math and science, but I'm terrible at spelling. All right,
Yeah.
so one chromosome might carry like hair color, but you get one from your mother and one from your father, or maybe eye color, or maybe skin color, or maybe it's your height, or maybe it's your hormone levels, or whatever it is that's on that, whatever that section is discussing, whatever topics. So these topics are found on different sections, and these sections are your chromosomes, like just like items described are in different chapters of a book. Well, the comparable here is, have you ever heard of like in the Bible, there's the King James version, the New International version, the ESV version, the different
Right.
versions of the Bible, right? They all
Yep.
discuss the same things, but they don't discuss it the same with the same words. They have different language, they have different codes and whatever. So these are like different versions, okay? Different versions of the same basic uh, content, okay? Same content. It doesn't mean the same codes. It means that we're going to talk about the same things of the same of the content. All right. So that's what homologous chromosomes are. Well, here, these are called homologous chromosomes. She got one from her mother, and then she got one chromosome from her father that discusses the same topic. So a sex-linked trait in human beings is going to be color blindness. It's found on the X chromosome. There are other sex-linked traits, but that's a very common one. Another one would be there's a what is it? It's a blood disorder of some type. Let's see, what is that?
Sickle cell?
I don't think it's sickle cell. I don't remember right now, but let's just go with color blindness. So a woman can get a woman. A lot of times, a woman has a father that was colorblind, and I mean, her mother may not be, but see, let's just say if there's a little c here, let's just say that big C would be, no, let's say big E. So if this X carries a big E, which means good eyes, and this X carries a little e, which means color blindness, then the mother would not be colorblind because the big E dominates the little e. Healthy vision blocks the colorblind trait. But she got this trait from her mother or her father. But a lot of times her father would be colorblind if he had this trait, because if he had it, he would have a little e, and there's nothing on the Y to block it. The Y is blank because the Y does not carry that gene. The Y is a very small colorblind, or excuse me, the Y is a very small chromosome, so it doesn't carry a lot of the traits that are found on the X. So if a man gets one copy of a bad gene on a sex chromosome, he's got the disease. A woman has to get shot twice with the disease. She's not going to be colorblind unless she has two copies of the gene.
Gotcha. Okay.
So if a man has normal vision, he has a big E. If he has the little e, he's colorblind, right? So that's the way sex-linked traits. So when the man's producing his sperm, he gives an X. Whoops. Here he gave an X. This is going to go down. Here he gives a Y. Well, she gives an X. Whoops. And gives an X. Whoop. Tab. So if she gives an X in every case, then she has no impact on if that child is a boy or a girl. The father is the one that determines that.
Right, right.
All right. So this is why 50% of the offspring are basically males and 50% of the offspring are basically females. So that makes sense?
Yes, sir.
Let me show you what would happen if the female carried a Y chromosome. All right. Let's just say, well, that would not make any sense, but let me show you what would happen. We would have X, Y here, and then we would have Y, Y here. So now you basically have two hermaphrodites because they're in the middle. Let's say this is male and this is female, then these would be what, hermaphrodites or something? That's not accurate. Okay, obviously that's not the situation here, but this would not work. So the designer of life made a system that works by using males as the carrier and females. Excuse me, males as a carrier and female as a non-carrier of the Y chromosome.
Gotcha. Okay. Understood.
Sorry, the reason why I asked for you to have the notes is because when I'm typing and using notes, my brain is thinking about
It's really hard.
And I need to be aware of what my mouth is saying instead of what I'm doing with my hands. So there's the picture on that's how sex chromosomes work. Now, for non-sex chromosomes, this is going to be a little confusing. You have autosomes. Autosomes look like X's. They're not X's because they're not sex chromosomes, but they're shaped like an X, basically. In fact, they're really shaped more like a parenthesis. So it's kind of like having parentheses turned in the outward position. And by outward position, I'm thinking, here, let me show you with a picture. Let me increase my font again. Are you still with me or did I lose you?
No, I'm still here.
Chewy hears somebody.
Yeah. I heard that.
That's my wife coming in, but she doesn't know it's my wife yet. She'll know it's my wife when they get to the door. All right, so we have boom. So and really I need to put a little dot in the middle. Let's see.
Oh, okay, yeah, I remember that. Yeah.
So there, well, that doesn't work. But so you have these would be what's called sister chromatids. The one on the left is an exact copy. These are not homologous chromosomes. So you have a chromatid from a parent. A chromatid copies itself to become a chromosome. And when that happens, you get both sides. And they're connected in the middle with a dot called the centromere. All right, so let's say that this is the chromosome that you got from the mother. Well, the father is going to give another chromosome similar to that. So it would be there. So now you have one from the mother and one from the father. And together, Chewy, knock it off, girl. Together you have what's called homologous chromosomes, or if you're in a hurry, they're called homologs. Okay? Homologs. Homologs is the same thing as homologous chromosomes.
Gotcha.
Okay.
Yeah.
All right. My wife came in, so the barking should be over with now.
Okay. Homologs. All right. So, Lee, are you done with that part? Because I want to ask you something else here.
Yeah, that's the basic terminology right there. Okay.
Okay.
And the fact that this is a language, let's think about this. Let me stop this screen share here for a minute.
Okay.
And I hope you don't mind if I put a little preaching. People don't have to believe what I say here. They can ignore it. Okay, good. You close that out. They don't have. I'm not saying believe in God. Okay, if you want to believe, you can believe. If you don't want to believe, don't believe. But right there, just knowing that DNA is a language. Think about that. Language always has an author. Mm-hmm. There's no language on the. You're going to tell me you went to the moon and you saw NWA Cane Corsos written in the sand, and you're going to say that's an accident? You know that if that's written in the sand, it had an author, because the scribbling in the sand doesn't mean anything.
Right.
What means something is the message behind it. And so, you could see if you went to the moon and you didn't speak language, if you just saw scratches in the sand, it would mean nothing. But because you speak a language and that was written in the sand, now that has an author. And so DNA is a language, and language has an author. It has a source. But anyway, that's a different subject, and I didn't want to preach too much, but there's science behind this.
Yeah. Hey, this the NWA Canine Corso show. Anything goes. That's funny. I had a minister on today. We was talking about this.
Yeah, people that think that scientists are not believers don't understand the complexity of language. There's if anybody of your viewers want to learn more about it, there's an excellent speaker by the name of John Lennox, not John Lennon, John Lennox. He's a 3-time mathematician doctorate that debates and destroys people like Richard Dawkins. He
Oh,
absolutely
really?
destroys all. The dude he's a great mathematician, and he really proves mathematically how anything that's as complicated as language always has to have an author. And an author, life cannot write language. It's impossible for life to write language because the very first cell had to write a code that the second cell understood, and neither one of them had a teacher. That would be like you learning English without a teacher.
Mm-hmm.
It takes a complex being to do that. People very slowly did that by collaborating and trying to communicate. They'd pick up a stick and point,
Yeah.
caveman or whatever, if that's what
Right.
you believe, and it made no sense. So eventually, we were able to come up with language. But to take non-living things and do that, the first living cell didn't have a teacher. It was the first cell. So how are you going to get that language? So DNA is a very interesting subject.
Right.
In fact, that's why I studied animal sciences, because I love animals and I love dogs, but I also am a believer, and I was trying to pursue the truth. And when you go to college and you start studying this stuff, if you're a believer, there are some people in the community that don't want to have serious conversations about such things because they think it's like fantasy land. And my thoughts are, well, humans coming from Iraq is a much bigger fantasy.
There you go. Hey, Lee.
Anyway, I derailed your subject. I'm sorry. What's the next topic?
No. I love it. I love it. We more than just a dog show. We men too. You know what I mean? So
That's right.
can
You
you
know, if we live 100 years,
Uh-huh.
how many days are in a year? 365, right?
365. Yep.
So if you live 100 years, you know that's only 36,500 days.
Oh wow. And we're not even going to discuss how many hours that we don't even take time to ourselves.
Man, we waste the limited 36,500 days is not very many.
Life's just fast. So here's another one, brother. Can you explain the difference between homozygosity and heterozygosity in simple terms?
Yeah, excellent job enunciating those words.
Man.
So, homozygosity and heterozygosity basically mean that you have a very high allelic frequency of certain traits within a population. And in this case, it's within an individual. So it's not always high frequency if it's in a single individual, but if it's in a population, let's say, for example, a breed, the golden retriever, that breed has a very high degree of homozygosity for being gold. All the dogs are gold in golden retrievers, right? So that means that every dog is carrying a homozygous combination, two codes that are exactly the same.
Right.
And I'm assuming something like a golden coat is a monogenic trait, which probably is, because it's probably related to a red dilute, or not a dilute, a red suppressor. We have 4 or 5 different alleles in the canine genome that affect color. And I'm not saying 4 or 5 colors. I'm saying 4 or 5 codes, at least 4 or 5 codes that affect color. One of them is going to be a black yellow. And then after, on that combination, you have another. So you have one loci. The loci is the location. One loci affects the dog is either black or it's yellow. Now you have another location that has nothing to do with yellow dogs. But if the dog is black, it can modify the black to a brown. And that's why you have black and yellow labs, but you also have brown labs. Every brown Labrador is actually a black Labrador modified.
Really?
Yes.
Okay.
You can have a yellow lab carrying the modified brown gene, and you won't know it because it doesn't have any black to turn brown. Maybe the nose might be brown because the nose is usually black. All right, so it only affects the black pigment and turns it brown. Then you have another loci, a third location that can turn the black. It only affects the black again. It doesn't affect the yellow. It can turn the black to a blue. Okay. Now, if you have the brown and the blue at the same time, that's where you get tawny or champagne. So you've seen tawny dogs or champagne colored dogs, kind of like the color of this stripe behind me. Right. Not quite, but that's the best analogy I have. The blue dogs are kind of like my shirt. They're kind of a gray. So you have black, or you have gray, or you have brown, or you have tawny. The tawny is a diluted brown. It's kind of like a tan color.
Mm-hmm,
Okay.
mm-hmm.
So, and
And
then
the
you
blue,
have,
the
go
blue
ahead.
is the diluted black, right?
The blue is a diluted black. So that
Okay.
means you have to have two copies. And
Mm-hmm.
then, and that was something else that we were going to discuss is dominance versus recessive, but we got that later on in the outline. And so
Right.
you asked about homozygosity. Homozygosity is when an individual, or homozygous is when an individual has two copies of the same gene. Homozygosity, I tend to think about it as a population having that frequency more often. And heterozygous is when an individual has different codes. So I want to put one finger up and one finger down. They're not the same. So there's something that's different. Like maybe this is a big A and this is a little a. That's heterozygous at a single loci,
Right.
a single location. And so if you have homozygous is the same, homozygosity is the same in a population. As far as I'm concerned, you could argue that it's for an individual as well. And then you have heterozygous is when they're different, and then heterozygosity is when they're different within the population, basically. But again, you could even argue that heterozygosity does apply and homozygosity does apply to an individual in certain terms. It depends on if you're dealing with line breeding and you're doing an outcross for the purpose of increasing hybrid vigor and things like that. Hybrid vigor is heterozygosity.
Okay, gotcha.
Or you could say, or one more thing I want to say.
Yeah.
It doesn't have to be multiple individuals, but it does. If it's not multiple individuals, then it's multiple traits. So if you're dealing with one individual, then you're talking about many traits. And if you're talking about one trait, then you're dealing with many individuals. That's basically what way I would say it. So you could
Okay.
be homozygous for many traits, or you could be heterozygous for many traits within one individual. And you could also do the same thing within a population. For example, let's take size of the English Mastiff. They have a high degree of homozygosity for size,
Mm-hmm.
and they have also a high degree of homozygosity for fawn with black mask. That doesn't mean it's all, but there's a lot of it. There's there's a few outliers like piebalds and whatnot or
Right.
brindles, but most of them are fawn with black mask. So now you're dealing with homozygous for multiple traits. So that would be homozygosity. It's a plural form of homozygous.
I got you. Okay. Okay. So what are simple dominance, codominance, and incomplete dominance?
Yeah.
How do they differ from an allelic? I hope I'm saying this right. Allelic frequency.
Yes. I see this misconception a lot. So this is one that I should have addressed when you first started. People will look at dogs and they will say something like, in my line, blue is dominant because they have blue all the time. That's not dominance, okay? Blue is always recessive to black. The reason they have blue all the time is because, let me go back to my map here,
Okay.
or my picture. There's a delay in the.
Okay. I'm waiting on it. Hey, y'all, let's get the likes up, please. Let's get the likes up. Here we go. Lee, I see it. I'm gonna pull it up. There we go.
All right. So now let's cut this. Oh, that's not what I meant to do. Edit, cut. That's not going to work. All right. I just got to delete them one at a time, I guess. All right. So let's say we're dealing with a black dog versus a fawn dog. Okay.
Mm-hmm.
And then we have over here a black and a fawn. So here we have big B. That's black. That's dominant. Here we have big B, little b. That's black, but it's heterozygous. It's dominant, but here we have homozygous, but it happens to be the homozygous. Here we have true dominance. Dominance is only recognized when you see a mixture of type. One trait blocks the other. Here we have dominance, but right here we have a recessive. And so now if we take this recessive individual, let's say we have this one right here, and we're going to change it right here, and we're going to breed that recessive individual Okay, my default doesn't like that lowercase letter there.
Okay.
Let's see, I can do that. All right. Now, when we breed this individual, we have big B, little b, and we have little b. Okay. So what happened is we have increased the allelic frequency of the little b by breeding a homozygous recessive. Now, let's say that this is a trait that we like the blue dogs, or in this case it was that I should have used the D and the big D and the little d. Like here are, let's say, F and little f. I should have used that full color expression or diluted color expression, but it doesn't matter what letters you use. So let's just say that big B is black and little b is blue. Well, if we like the little b, we like the blue dog, we're going to breed, and we want, because let's say we can, a person that's breeding for money. Okay. Now I breed for health. I breed for function. I don't breed to peddle puppies. If I was doing that, I'd have little lap dogs. I'd have me some little blue Frenchies or something.
Yeah.
Yeah. They don't hurt it. You know, you can put them in a 6x6 kennel that costs you $100 and raise 3 of them in one cage as long as you change it, you know.
Yeah, a bag of dog food lasts you 3 weeks.
Yeah, or a month. 50-pound pound bag of dog food to last them a long time.
Right.
But if you were just trying to breed for money, thank you, baby, and you wanted them blue puppies that were going to sell like crazy, then you don't want to breed any black dogs. You're trying to increase the allelic frequency of the blue. So now you have a blue parent. Well, when you have two blue parents, oh, come on, it doesn't like it that there we go. I got to get in front of it so it doesn't default to autocorrect, you know. Now the population is all blue. And you'll see people say that, oh, blue is dominance in my line because they're all blue. That is not dominance. That's allelic frequency. What you have done is you've made the frequency of the trait more popular. Okay. Yeah. Now, there's an equation called the Hardy-Weinberg equilibrium equation.
Oh, okay. Somebody was just talking about that. Okay.
I don't know if it's URG or ERG. Like I said, spelling is not my strength. Hardy-Weinberg equilibrium.
Yeah, I'm not gonna try to spell it either. I've been out of school too long.
Yeah. So the Hardy-Weinberg equilibrium equation includes 2 equations. One is 1 equals P plus Q. And there's different variants of this. I should say P plus Q. It should be lowercase q. Now, there's different variants of this. In some cases, this is if there's only 2 alleles. Like in the case above, we have black and blue. Okay. This P represents the frequency. Whoops. P represents the frequency of the black gene or black allele. Okay. And Q represents the frequency of the blue allele. Okay. So let's say the black allele is, in this case, let's say 70%. Okay. That would be 0.7. Okay. And if that's 0.7, well, the equilibrium equation says 1 equals P plus Q. So if this is 0.7, that means this is going to be 0.3. Right. And so now we do the same thing here. B. Oop, this should be a little b. My autocorrect did that to me. And 0.3 and 0.7. So that means 49%, because 7 times 7 is 49, right? So 0.49, 49% of our, oops, that should be a big B. 49% of our population is going to be homozygous big B. Here we have 21% that's going to be big B, little b. Here we have 20. Oh, this should be a little b. Autocorrect did it to me again. This autocorrect is going to destroy my lives. All right. So I think autocorrect did it. I'm blaming autocorrect. I don't know. Maybe I did it. Here we have 21% again. And then here we have 0.3 times 0.3, which means only 9% of the population, 0.09, is going to be blue. Okay. Now that's on the allelic frequency of the entire population. This is not based on the difference between a Punnett square and Hardy-Weinberg is a Punnett square does parents. Hardy-Weinberg does not do parents. Hardy-Weinberg says, okay, we have 100 individuals in the population. And when we have 100 individuals in the population, out of that 100, we're going to look and see how many of them are blue. And then because 9% of them are blue, the square root of 9 is 0.3. That means even though the expression of the trait is really rare, the gene is really not that rare. It's 30%. Okay.
Yeah.
Now, what this means is 1 also equals p squared plus, I'll fix that in a minute, plus 2pq plus q squared. Oh, ah. Now I need to fix that. Let's make this font bigger.
Okay.
And then we need to fix this 2 right here. That should be a squared. And then this should be squared. Now, in some cases, you're not just going to have 2 alleles. There's like just black or blue. You might have another alternative. For example, blood types. Blood types, you have big IA, big IB, and then little I. Little I makes blood type O. Big IA makes type A blood. Big IB makes type B blood. And then if you get an A and a B, then you have type AB blood. So
Okay.
in those cases, when you have multiple alleles, you also have plus R. And in here, that makes this equation a lot more complicated because now you're going to have to include the R. So to do that, you have plus R squared, no, 2PR plus 2QR plus R squared. All right. And this is when the numbers start to get over people's head. But let me do something here that's going to fix this layout. All right. So now the equation looks a lot harder and a lot more complicated, but it's really not. And I can show you why it's not. Let's look at these two real quick, and then I'll show you why it's not that hard, even though it may look hard. All we're going to do is we're going to take this here, and we're going to add a column to the right, and then we're going to add a row underneath, and then we're going to add our R, whatever the R is. My apologies, it's not going to be centered. So let's say R. So I need to take something out here. I'll leave the 7 in here. Let's say the R in this case, just so I don't have to do a bunch of math, is going to be equal to 0.0. It's not expressed in this population. All right. Now here we have BR. Whoops. Big B, little r. Here we have little b, little r. Here we have, boy, that b is going to kill me. And then here we have RR. And then here we have BR. And here we have big B, R. And here we have R. And so what we have is in this diagonal right here, you have B squared, little b squared. So this is going to be B, this is going to be our Q, and then this is going to be our R. So that's the squares right here. Then you have the 2 B, big B. So there's your 2 PQ. If you see that right there, 2 PQ.
Mm-hmm. Okay.
And then here you have your 2 QR, which is right here. And here you have your PR. So you have each one happens twice. Now, the reason why they happen twice is because you only get 2 alleles. You get 2 alleles. You don't get 3. Even though there's 3 alleles that are available, you're only going to get 2 of them because you have one mother and one father.
Gotcha.
And that's really further than I think we need to go. on the math. I think that math is something that even somebody like me is only going to do once every 5 years, because you're looking at not an individual here. You're looking at a population. So let's say that you have a genetic defect. I can think of one genetic defect that we had in one of our dogs that we bought back in 2000. He had a trait where he had a kinked tail at the base of his tail. You ever heard of spina bifida, like the bulldogs?
Oh yeah.
You know how they have a corkscrew tail?
Right.
I don't want to see that. I don't want to see it. That's not why I dock tails, but because you'll see it real close to the butt. If I had a dog with a corkscrew tail, docking's not going to hide that. You'll still see it. It's because it gets the vertebrae are crooked. That is a genetic fault to be avoided, because that corkscrew tail is linked to the same thing that causes spina bifida, which is a kink in the spine. And if you have a kink in the spine, now you're going to possibly risk having dogs that are paralyzed in the back legs and things like that.
Yeah. That's good.
So we had a dog that had that, and in his tail 23 years ago. It was one of my foundation dogs. I've never seen it since. The time that I did Hardy Weinberg, I was actually looking. I noticed that we very seldom have blue dogs. And I did a Hardy Weinberg equilibrium equation on our population, looking at all the blue dogs that I've produced and then all the dogs that I produced. And from math, even though you might see it 9% of the population, which is 0.09, that means 30% of the population carries it, which is not that rare.
Right.
Because 0.3 is the square root of 0.09.
Right. Okay.
So I wanted to know how often, like for example, the first one of our foundation dogs had a tawny. I've never had a tawny dog. But we have had a brown dog and we have had a blue dog. So actually, I take that back. I probably did have a tawny, but I sold it as a puppy because I'm not breeding for color.
Right.
You know, sometimes you don't really get to see. Tawny is one of the few colors that it's hard to tell if it's a blue fawn or if it's a tawny until it gets a little older. I had like a silver dog. It was not, the gray dogs are kind of gray. You can see that they're gray. They're not really black. But we had one that was silver, and I think it was probably a tawny.
Right.
When it was young.
Yeah. So you just put it in a pet home.
Well, I didn't. If it worked, it worked. If it didn't work, it didn't work. But I'm breeding for performance, so it obviously wasn't the best perform. It may have been a nice dog, but I had other dogs that were maybe more common colors, but they worked better.
Right.
Which makes sense. I mean, think about it. If 80% of your population is a common color, well, you have 80% more likely to get a working dog out of that than you are the 20% rarest because there's less of them.
True.
You buy more lottery tickets, you're more likely to win.
Facts. Let me ask you this one, Lee. How does simple monogenic dominance differ from polygenic inheritance?
Yeah. So dominance, the reason why I said people confuse it with allelic frequency is they think if you see the trait, it's dominant. That's not true. Recessive is very easy to purify because if you have a dominant trait, I did this before, but I'm going to do it again. Let's say that the hat represents a dominant trait. And let's say my face is a recessive trait. Well, if I have two hats, I have a hat over here somewhere, or pillow. There we go. We have a pillow. If I have two pillows, you see pillow. If I have one pillow, you see pillow.
Right.
You never see what's behind unless it's pure. So whenever you have a recessive trait expressed, it's automatically pure. All right. And so it's way easier to breed a population that's pure on a recessive than it is to breed a population pure on a dominant, because on a dominant, you don't know if you have one copy or if you have two, because you only see the one in front. So you might be carrying a disease if it's a recessive disease, and most diseases are recessive. Not all of them. There are some dominant diseases, but if you think about that for a minute, the reason diseases are very seldom dominant is because diseases have a lower reproduction rate, a lower success rate. And since if it's diseased, you don't need two copies to die if it's dominant. If it's dominant, You only need one copy.
One copy,
And if you
yeah.
got one copy, it eliminates itself.
Yeah.
It's, it's not going to reproduce as often if it does reproduce at all. So spina bifida, for example, it's a recessive trait, but I'm assuming, but let's pretend it was dominant. Then if it's expressed before puberty, you're not breeding.
Mm.
If it's
Gotcha.
expressed after puberty, it might reproduce, but it reproduces at a lower rate because it's going to die younger. So maybe it reproduces a little bit, but it doesn't reproduce. Maybe if it's a teenager, it can still have a kid, maybe even two kids. But let's say they die when they're 20 years old. Maybe they had one or two kids, but they still died when they're 20. They didn't have very many compared to the norm.
Right. Okay. What is the founder effect, and why is it important in population genetics?
All right. Before we do that, that last question was, what was that last question?
How does simple monogenic dominance differ from
Polygenics.
polygenic inheritance?
Yeah. Yeah. So I need to clarify that one a little bit more.
Okay,
So
let's do it.
a monogenic trait is when it's controlled by one loci. So if you remember our terms here that we had in my list,
Both sides like
up here at the top,
Mhm.
loci is where it's found.
Yeah.
A monogenic trait is found on one spot. So that would be like a dimple chin. Very easy to control something that's only found in one spot. But if you have, let's say you have a light bulb in your house and you don't know where the problem is, maybe it's not the bulb, maybe it's the fuse box. Maybe you didn't pay your electric bill. Maybe the switch is turned off, or maybe it is the bulb. Now you have polygenics, 4 different things affecting that one bulb.
Mm.
So if the bulb is out, you don't know if you have a bad bulb, if you turn the switch off, if the breaker's off, or you didn't pay your bill. Make sense?
Makes a bunch of sense. Yeah.
So polygenics is a lot harder to change rapidly. Well, I shouldn't say it's hard to change rapidly. It's hard to control the change rapidly. You can change it rapidly, but controlling it and adjusting it,
Mhm.
it's almost like testing the meter on the light bulb, but you don't have a meter tester. You just have to try it again and try it again and try it again. And slowly over time, you can improve the polygenics.
Mm-hmm. Gotcha. Okay.
All right.
So
Now that question, what was the next one?
what is the founder effect, and why is it important in population genetics?
All right. So the founder effect, my wife's having to correct Chewy. She's wanting to play. Chewy's a nutcase. She is so hilarious. All right. So effect. Let me pull up a graph. Hold on.
Okay.
Knock it off, dog. Stop.
I thought somebody threw something at you, Lee.
No, she knocked over a drink. I didn't even need a drink. I got one here. Chewy, good girl. Come here. Come on, get up here. All right, you got to calm. She is the weirdest dog. When we feed her, it's almost like she has a energy rush. Most dogs, when they eat, they get tired and want to sleep. Not her. An hour after she eats, she is ready to go. This dog she has gotten a dose that's just, she's hilarious. All right, so I got a graph here, real nice picture of founder effect. We're gonna look at it, and I'm gonna do a screen share.
All right.
Whoop. All right. Sorry about that, Wendy. Thank you for cleaning that up.
Let's get
my wife's having fun over here cleaning up trees. Fortunately, it wasn't much.
Okay.
Good girl.
I've been cleaning up all day.
My wife's gonna get mad at me for telling Chewy's a good girl. All right. So let's look here. Can you see that picture?
Yes, sir.
All right. Now, if you look at a population, look at in this population, you'll see there's purple, 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 lots of purple, and about 50-50 purple and orange, right?
Mm-hmm.
Well, over here, let's say that you wanted to breed orange and you took a sample. Well, this sample, you got one purple, but the rest of them are orange. That means your new population, purple is going to be really rare, even though it was not rare in the past.
Mm-hmm.
So whatever you bring onto your yard, a lot of times people think that they're selecting desirable traits.
Mm-hmm.
Yes, you are, but you're also culling undesired. Because I think you're culling undesired more so than selecting desired. The reason why I say that is because this purple, you can see it. You don't want it.
Mm-hmm.
Now, these oranges, you think you want them, but really you only know that you want the orange. What about everything else they carry? You never breed to a trait, you breed to a dog. And
Right.
what I mean by that is that dog doesn't just carry that one trait. That dog is carrying all these traits. I mean the entire genome. So it may have what you want for one thing, but it
Mhm.
might have something else that you don't want for something else.
So you
So
breed for the total package is
yeah,
what you're
you
going.
got to breed for the total package. But
Right.
when we're doing that foundation work, you, the I get when we do that foundation work, the founder effect, what you bring onto your yard, that is, this is why I said, understanding genetics is important, but really selection is where it's at because you're very seldom going to actually pull out a calculator. And if you make breeding decisions because of a calculator, you're you probably don't know as much about genetics as you think you know,
Mhm.
because a calculator is not the way to make a breeding decision.
Gotcha.
You
Gotcha.
know, you got to look at the whole package. Um, and not only that, but you can have two dogs that have the exact same calculated numbers, and they be totally different dogs. They could be litter mates, and they could be different dogs because one has what you want and one doesn't. And if you're just breeding off the calculator, they're the same. They got the same number. What's the difference? There's a big difference when you go to test them. And so you've
Yeah.
got to always put selection over the calculator. What does nature do? Nature does not look at the dog's DNA. Nature looks at does it work or not. We had that conversation before talking about the grasshopper hiding in the grass.
Right. Right.
If,
Right.
if the grasshopper's a different color than the grass, if he's not green, then he's going to get eaten.
Right.
And
Right.
a cricket that's down on the dirt, they might be black. But if that black cricket gets on top of the grass, he's going to get tagged because you're going to see that cricket on the green grass.
That's
So
right.
that cricket needs to stay under the grass, and the grasshopper it doesn't matter. So you want to but they're not breeding for color; they're breeding for camouflage because color is irrelevant, but camouflage is not.
Mm, good point.
So, we have to put selection for performance. That's all. Mother Nature doesn't care what your pedigree is. Your daddy could be the Queen of Sheba, or your mama could be the Queen of Sheba. Your daddy could be the Prince of England, or King of England. You go live in the woods, it's do or don't.
That's right. Yeah, that's right. That's I do. Hey, and that's funny. I argue with a few people about that offline about like because I know it's I don't know if you ever met people who breed off a pedigree and supposedly like it don't matter. This pedigree is going to produce a great dog. I just no, you can't sell me on that one. I'm
It
sorry.
will. If a dog is really inbred, then it
Right.
should produce consistently. But if you selected
Right.
the wrong one, it might be consistent trash.
It might be. Yeah. And
So
then yeah.
you got to select the right one. Every litter has that apex. Not every litter. Every litter doesn't have the apex in trash, but every litter does have some distribution. And so there's some that are better than others. And
Exactly.
so you might have a really good litter, but a person with a and this is my strength. I'm not trying to be egotistical here, but we all have our strengths and weaknesses. I can't spell
Oh,
with a toot, man. You don't ask me to spell something.
right.
I'm gonna get half of it wrong.
Yeah.
But my strength is seeing details that a lot of people don't see. Like tomorrow, I'm going to pick up. I had a little fender bender on the back of my truck. Going to pick it up. I'm a little nervous about using this guy that I use because he's a small shop. I don't know him, but he had good reviews or whatnot. But he says you won't be able to tell if anything ever happened. It was really small, but he said you'll never tell it anything happened.
Hmm.
Well, I'm the kind of guy that'll see that hair spot in the paint,
Right.
and when puppies are running across the yard, they might all be sound, but I can see the one that moves the fastest and the most efficiently. A lot of people don't see the difference until I'm like, well, that one's faster. And I'm like, no, I don't think. And I watch, and I'll take off running, and it smokes them. And they're like, how did you know just from watching them move in the yard? Well, I don't know. It's like trying to tell somebody. Some people can play the piano without ever having to take a music class. I don't know how that happens.
Right.
I can't do it, but I can see things in animals that a lot of people don't see, and I think that's my genetics helps me be successful. My knowledge in genetics helps me be a successful breeder, but it doesn't make it. What made me a successful breeder is being able to see things that other people don't see.
Yeah. Yeah. Gotcha. Yeah.
Yeah.
Yeah. And that's another thing. I know my strengths and weaknesses. If you don't,
Yeah, you better know your strengths and
you better-
weaknesses. Hold on, my
you
wife
better-
wants to tell me something. What?
okay.
Do what? No, I'm good. All right. Sorry. Go ahead.
All right. You kind of already went into this a little bit, but let me see if you got any more to it. Can you explain the concepts of natural and artificial selection,
Yes.
particularly the role of overproduction and competition?
Yes. So there's 4 steps in natural selection. The first one is overproduction.
Mhm.
Overproduction means we have more than we can take care of. Now that's important. And people might say, that's terrible. That sounds like a puppy mill. It's important. Now I know that some people that our buddy on YouTube wants to say that's a spray and pray method. No, it's not. And I'll talk about a little differentiation from a scientific perspective because I'm not trying to be personal here. But I'll explain the scientific difference between what he's talking about. He says he only breeds like certain individuals and then he nurtures that individual so it becomes its best. That is not a reproduction strategy. That is a rearing strategy, a nurturing
Yeah.
strategy. Nurturing and reproduction are 2 different things. That's why there's what's called nature versus nurture. Which one matters? So caring and developing is important, but that is not a reproductive strategy. That is a nurturing strategy. Okay? A
Yeah.
reproductive strategy always includes overproduction. Because if you don't have an overproduction, then you don't have genetic variation. And you cannot evolve or improve a population unless the population has variation. You need those ones that are better than the rest. Breed the best, cull the rest. Breed the best, bury the rest. However you want to say it. Breed the best, sell the rest. Whatever it is that method you use, you can sell them to pet homes. You can get them spayed or neutered, or you could euthanize them. Those are all effective methods of culling. Culling does not mean killing; it means not breeding. Culling is removing them from the breeding population.
Yep.
Yeah, you're removing them from the breeding program. They may still be great dogs, but they're not the best. Okay, because there's the best, there's great, there's good, there's okay, and then there's the really crappy. Okay,
Right.
nobody wants really crappy. Some people are okay with okay because
Mhm.
they just want a dog to play with the kids as long as it's stable. It doesn't have to do anything. You know, if it lives 10 years and it's a happy dog, they're happy. Other people like, no, I want a dog that's going to catch a hog or defend a protector. Other defend and be a protector. Other people are like, I don't want just a protector. I want an annihilator. When you step on my toes, it's over. And I don't
Right.
care how hard you get hit. You keep moving forward. Those are the ones that are the best. And so you have to have overproduction, and you're always trying to find the ones that have those traits that you desire. Now, so you have overproduction, then you have variation, and then you have competition. You have to separate the ones that are worth it from the ones that aren't worth it. And when I say worth it, I'm not talking about worth living. I'm talking about worth breeding, right? And
Right.
then if they find the resources in nature, it's overproduction, variation, and competition for resources. So the ones that find the resources live, and then they get the last step, which is the opportunity to reproduce. They have to find a mate, they have to find a territory, they found food, they were able to evade predators, so now they have the opportunity to reproduce. That's how nature does it. It
Mhm.
tests them and says you do it or you don't. Now, in artificial means domestic. We are not putting our dogs in the woods and say find your rabbits. If you don't find a rabbit, you don't eat. We have our dogs in a kennel and they're fed every day, or in the home and they're fed every day. They're given water every day. They're when they get a disease, we give them medical care and stuff like that. So they are not competing in a natural sense. They're competing in an artificial sense. This dog will yield to me. I mean, I popped her, but I popped her on the butt a minute ago, telling her to calm down. It's almost like playing with her.
Yeah.
That wasn't even a correction to her. She's like
Right.
wiggling.
Yeah. Oh,
Hey,
man.
yeah, smack me again.
Yeah.
You know, she's sitting here right here wanting me to give her a piece of my food, but
Yeah.
she's a great dog. But anyway, um, they are competing not for resources because I'm gonna feed them all. I even feed the ones I don't want until I figure out what I'm gonna do.
Right.
You know, sometimes it's spay neuter, sometimes it's a pet home, sometimes we might do something else. You know, depending on what's going on, I might give a dog to a hog hunter or something. But I don't give dogs to people except for hog hunters. I might give a dog to a hog hunter on a rare occasion because they're going to tell me the truth. The dog worked or it didn't. And that's one thing that it's nice to have a place where I can deal with culls in such a cut and dry manner because that hog hunter, if it works, hey Lee, this dog just needed some work. He's doing great. Or Lee, you're right. This dog was a cull. We'll take care of it. You know, because I don't care. Any breeder that says they don't have culls is a liar, or
Big liar.
they have very low standards. Because the higher your bar is, the harder it is to meet that standard. I remember 15 years ago, this guy asked me, and I was talking about the different dogs in my kennel, and he said, "Man, Lee, you named something off every single one of your dogs. You don't like any of your dogs?" And I'm like, "No, these dogs are great, man. The best dogs in the world, as far as I'm concerned. But I'm trying to find things to improve so the next generation's better."
Because you breed for stuff. Yeah, you looking at your animals, and you have to.
I don't know how old you are, but man, back in when I graduated high school in the late 80s, a car that went 0 to 60 in like 6 seconds was fast.
Man,
now,
I can't believe you said that. Oh, the way you said that back in the 1900s.
in the 1990s.
Yeah.
Yeah, a car that went 0 to 60. Huh?
I'm 47, so I remember the 1900s. Yeah. It's crazy.
0 to 60 in 6 seconds was fast. Now, man, they have SUVs that do that.
Yep, easy. Yep.
My daughter's car, a Lexus RX 350 that's a 2010, probably does 0 to 60 in 6.5 or 7 seconds. You know, it's not fast anymore.
No.
So, what was once great becomes average when you are always trying to improve. So maybe those dogs that I had 20 years ago were great for most people, but I was trying to push it to let's take it more. I want more. And no matter how high you get, I mean, there's going to be a time and day that we're going faster than ever, right? And so this is just an evolutionary process. And so they compete not for resources, they compete to serve in an artificial world. And if they serve, then I give them what they need to live. And then they don't get to breed, I breed them. And what I mean by that is there's a difference between them going to find a mate. I don't have 20 dogs in a big kennel and they just breed randomly, or they fight for their mates. That's not what happens here. I'm looking for certain individuals that I pair up with certain individuals. And so, yes, I'm selecting the best, but I'm also I do pair pedigrees, and I do pair some math, and I do pair some selection, but that's only after I've done all this other stuff of making sure I have the right individuals first.
Right. It's almost like you checking your homework once you completed your formulas and stuff, and you go back and check it. Is when you saying you add in all your calculators and COI and all that stuff.
Right. That's right. Genetics is not going to make a person successful, or it also won't make a person fail, but it will make them fail or successful faster.
Right. Yeah, because one thing Schoolboy, he would always tell me, he said, you got to remember, before science, it was the breeder. You know what I mean? And they didn't know the terms we know now. I know guys, older guys that they don't do no health tests. He said, "I'm not doing that crap. My dogs don't got this stuff. I'll do it." And guess what? He don't have all those defects and diseases.
Well, one of the reasons why I like the game bred American Pit Bull Terrier is you have to look at the people that were involved with those dogs. They may have made cruel, unethical decisions that the dogs paid the price for, but the ones that made it through that founder effect, they were pure. They were purified of those diseases. Because if a man who's going to fight a dog for money, let that dog go through hell and back for money, has a dog that cannot perform, he's not going to even feed that dog.
Mhm.
So, as cruel as that is, that's what made the American Pit Bull Terrier the top performing animal in the world. It has, if you're dealing with game bred lines, I'm not talking about show lines. If you're dealing with game bred lines, you'll almost never find hip dysplasia. Now, some people might say, well, the pit bull has 20% hip dysplasia. Yeah, and 80% of those are from show lines. And the reason why is if you take somebody that was a conditioner and they put that dog on a treadmill and they run that dog and get it in shape, and then it rests, and at 3 years old, arthritis starts setting in. That's going to affect its conditioning.
Yeah. He wouldn't make it.
They're going to see it. They're going to. I'm not using that dog. He can't even run the next day.
Mm-hmm.
They don't know that he has hip dysplasia. They just know that dog can't run the next day, so they're not using it. There's a reason. There's a reason the old sled dogs and huskies and pit bulls, if you get them from the working lines, like the dogs that pulled the sleds. I'm not. Huskies don't look like that picture you see on the internet at a dog show for a husky. You go type in AKC husky, you'll see one picture. Go type in Iditarod, 2,000-mile sled race. Now you're going to see a real husky. They don't look the same.
Right.
The Iditarod dog has to go 2,000 miles.
Ooh.
So it has to have it. Do it or don't.
Right.
Yep.
Yeah. Understood. Another big one people want to know and get it explained from you is, what is genetic drift and how does it impact allelic frequency within the population?
Yeah. So genetic drift and gene flow are a lot of times mixed up.
Mm-hmm.
And they shouldn't be. So let me ask you, here's how you can remember the two so you don't get them confused. If you're on a pond and the water's not flowing, you're going to drift, right?
Mm-hmm.
If you're in a river and the water is flowing, you're going to flow. Now, which one moves faster usually? A river or just drifting?
A river.
A river.
Mm-hmm.
That's gene flow. Gene flow is faster. Think about a river. Whenever you see that word gene flow, it moves faster. The reason it moves faster is because gene flow is when you outcross.
Mm-hmm.
So you're changing the genes very rapidly.
Gotcha.
So what both gene flow and genetic drift, both of these change the allelic frequency in a population. But gene flow does it by breeding out of the population. Like let's say, for example, 500 years ago, if you went to China, you'd only see Chinese people with black hair. If you came to Europe or Sweden, you'd only see white Caucasian people with blue eyes and blonde hair. If you went to Africa, you'd see dark pigmented black people. Mm-hmm. That was because they were isolated populations.
Right.
Well, the plane, the train, the car, the boat, they got rid of those isolated populations and it allowed migration. Well, that allowed, it's kind of like outcrossing. It allowed the genes to rapidly change. So today we have a lot of races that have combined, and eventually racism is going to be gone because we're no longer geographically isolated. Well, gene flow is when you're having one population mixed with another. And so it very quickly changes the allelic frequency. And this will drive competition to a higher degree to some level, because when you have more variation, you have more competition. And the ones that are weaker are going to die out. and eventually they'll be purified for the best performing individuals in that particular environment. There's a reason black skin was found around the equator. It protects you from sunburn, and there's a
Right.
reason lighter skin was found more northern or away from the equator, unless you get really far north where there's snow and reflection of light, and that's because you need vitamin D also. And my skin is not actually white; it's transparent. If you peel our skin and hold it up, light goes through it, and that means the vitamin D can go through it, because you and I both need sunlight to make vitamin D.
Mhm.
But since our ancestors evolved in different areas, they needed different levels of protection so they
Right.
wouldn't get burned, but would still get enough. So if you're in more light, you need darker skin so you don't get cancer, because you're still getting your vitamin D because there's so much light. But if
Right.
you're in lighter areas, I don't know if you know this, black people almost never get skin cancer, and they almost never get
Right.
sunburn because they're protected. But what they do get is rickets, and that's because they're not getting enough vitamin D. If you have a black person in a dark skinned black person in a northern environment where there's very little sunlight, you have a long winter with very little light, if it's very overcast, and you have poor nutrition, then they're not getting enough vitamin D and they can get rickets. So there's a balance between what is optimal for every environment. Well, this same thing is true for dogs when it comes to performance traits. We select individuals in a population to perform at a certain niche. A niche is a task. And so when you select the traits that do really well in that particular task or whatever feature it is that you desire, outcrossing can be risky because you might lose what you gained.
Mhm.
However, outcrossing can also be a benefit because you might gain something that really excels and you didn't even know it.
Mm.
Um, and this is the basis behind the band dog. The band dog is the idea of taking the size and power and strength and defense and loyalty of the mastiff and crossing it with the tenacity and ferocity and athleticism and health and determination and gameness and intelligence of the pit bull. Now, sometimes you get the laziness of the mastiff and the
Mhm.
health problems of the mastiff
Mhm.
and the lack of determination in a mastiff, but then you get the size of the pit bull. So that's like you got the worst of the worst. You got the
Yep.
weak, the smaller dog, the less muscle mass, and you got the less determination. It's a disaster. But if
Mhm.
you're dealing with the right individuals and you're selecting the right individuals, then you can get some really apex individuals that have the best of both. And so outcrossing can be a way of finding a very high performance individuals. In fact, if you look at some old pedigrees, you might see that a lot of the best producing individuals were outcrossed individuals. Not always, but a lot of times they were. But that doesn't mean every outcross works, because sometimes you get the worst with the worst, sometimes you get the best with the best. Sometimes you get the best of one with the worst of the other. That's not any good either. So you need the best of both. And so when you get the best of both, that's when outcrossing really is beneficial. Now, isolated population, over time, you test it and test it and test it. And eventually you slowly weed out those individuals that carry that express the weakness. Now, there may be other individuals in the population that don't express the weakness, but they carry the weakness. But
Mm.
because you're always removing the ones that express it, you're slowly going to change the frequency of that allele, and
Right.
it's going to become rare, more rare, and more rare, and more rare, and eventually it'll become very rare, and you might only have a few carriers, and then eventually even the carriers will fade away. Um, for example, you've heard of sickle cell anemia.
Yeah.
That's do you know why that's found in black people and not found in white people?
No, no, I don't.
Yeah, so here's why. Do you know that sickle cell anemia, even though it's a negative in normal situations, it prevents malaria?
Oh, really?
Yeah, so if you carry sickle cell anemia, you have a very low chance of getting malaria.
Oh, wow.
Now, when you're next to the equator, there's a lot of mosquitoes. When you go into a place that's wet and a lot of mosquitoes, malaria will kill you quicker than sickle cell. So
Yeah.
they actually had resistance. So sickle cell anemia, today we have vaccines that you can get or whatever they do to prevent malaria. And
Mhm.
so now sickle cell no longer is a benefit at all. It's only a negative.
It
But at
is.
one time it was a positive. It was not good, but it had its pluses and its minus. It's kind of like, is endurance better than strength? Well, it depends on your environment, man.
Mm.
In some places you want to be strong. In some places you want endurance. Some
Right.
places you want a little bit of both. Well, sickle cell anemia is like a little bit of both. You don't
Right.
have endurance, but you do have disease resistance.
Yeah,
You got
yeah,
one disease you got
yeah.
resistant of one disease by having another. And so
Right.
it's kind of an interesting thing. It's when the blood cell takes the shape of a sickle, like a banana, when it doesn't have oxygen. When it has oxygen, it's a round cell, but when it doesn't have oxygen, it turns into a sickle shape, and so it impedes blood flow. And because
Right.
it impedes blood flow, it has an effect on malaria.
Gotcha. Gotcha. So Lee, what is the difference between species and breed or race in terms of taxonomy? Is that how you pronounce that word?
Taxonomy.
Taxonomy. Yeah.
And I noticed that the other day when we had our video, I skipped a step. So, and the reason why I skipped a step in taxonomy years ago, it was they changed the levels of taxonomy. By the way, there used to be fewer levels than there are today. And at my age, we sometimes have a default to going back to the old way: domain, kingdom, phylum, class, order, family, genus, species, and then you have subspecies after that. So you couldn't see my fingers, but you get the point. I was
Yeah.
naming them off. So
Right.
the first one, domain, there's only 3 domains. All organisms in life are one of 3 domains. You have bacteria, archaea, which is a type of bacteria, and so archaea, and then eukarya, EUKARYA, or something like that. So you have basically bacteria and archaea are both single-celled organisms. Anything that's a multicellular organism, like a fish, a snake, a reptile, a human being, a dog, whatever, those are going to be in the eukarya. And then after that, so that's domain, and then you have kingdom. And kingdom, you're going to have there's 6 kingdoms, and then you go down to phylum, and you get more, and then you have division, and you get more. And by the time you get down to species, there's millions of species. So think
Hmm.
about it like you have your kitchen, or you have your house, then you have your kitchen, then you have your drawers. Every level has multiple levels inside of it. So a house is one. It has multiple rooms though. One of those rooms is a kitchen, and that kitchen has multiple drawers. But one of those drawers is silverware. And then in that silverware drawer, you have multiple segments for like knives, forks, spoons. And so every time you go down a level, you get more and more categories. And by the time you get to species, you have probably billions of, or if not millions, probably billions of different species that are out there at the microscopic level. Now, we don't have millions of mammals, but we have lots of bacteria. So when you're at that fine level of species, and this is where again scientists do a lot of what's called the bait and switch. There's people that have an agenda to prove something instead of seeking the truth, and I don't like those type of scientists. I think scientists should seek the truth, not seek to prove. And with that said, let's take 2 words real quickly: adaptation and evolution. These 2 words are very, very similar. Adaptation is change within a species over time.
Hmm.
Sometimes that change can be within a season and within one individual as it adapts to new. For example, if you live in a really tough environment and you have to run a long ways every day, you're going to start to build endurance. That's a personal adaptation to a new environment. But there's
Right.
also adaptations in type where your skin gets darker, your skin gets lighter because of the environment, but you're still the same species. You're still the same kind. Okay, so you're still a human being. Um, the That's adaptation, change within the species. It's still the same species over time. Evolution is change of the species, where it becomes something new, different than it was before. Well,
Hmm.
the definition of a species is a group or population that can reproduce with one another and then have viable offspring also able to reproduce back with the parental population. So if you have a horse and a donkey, yes, they can reproduce and make a mule, but the mule is sterile and cannot reproduce. Therefore, the horse and the donkey are 2 different species
Mm.
because the mule cannot reproduce. No matter how many times you do it, the mule cannot reproduce. And this is because I can't remember which one's 56 and which one's 54, but one of them has 56 chromosomes in the haploid state. or diploid state, and the other one has 54 chromosomes in the diploid state. Now, diploid means we're counting the chromosomes from both parents. Well, when you produce a sperm or an egg, you only provide the DNA for one parent. So what's half of 56? It's going to be 28. What's half of 54? 27. So if a horse donates 28 chromosomes and a donkey donates 27 chromosomes, and I may not have the numbers exactly right, but you get the point. There's one left over. So some of them get homologs, the match partner, but then there's one over here that doesn't have a partner. And there may even be others, because even though they have similar numbers, maybe they didn't match. So you might have a couple that don't have matches. Just because you have two chromosomes doesn't mean they're going to match. They have to recognize each other.
Right.
So if they don't recognize each other, they're not going to have that affair or pairing. So the chromosomes have to match. Well, a horse's chromosomes will match up with a donkey's chromosomes good enough to produce a viable offspring. But the offspring will not be able to produce gametes because the chromosomes are not homologs. And in meiosis, the homolog chromosomes have to separate. Well, some of them can't separate because they don't have a partner. And so therefore meiosis doesn't work properly in a mule. And so mules are sterile. So this is the definition of a species, is when the population can reproduce and the offspring can also live and reproduce. That means it's the same species. So races are kind of an illusion. Our world is so divisive and hateful that they love to separate. They very seldom are willing to unite. Just because
But that's how it works. That's how they hold their power.
Yeah, exactly. Because if they realize that we recognize we're through what is it? Truth will set you free. My wife and I have different hair color or a different eye color. We may have freckles or not freckles. We may, that doesn't mean I should hate on her because of some of her traits. What's the difference between hair color and skin color? There's anatomically, the difference between you and me genetically is so small. It's not even, if you were to weigh a dog, it's not even a gnat on a dog's ass. It's too small to even worry about. You're not going to weigh it. You're not going to find the difference. The difference is cosmetic. It's all it is cosmetic. You're talking about 0.00001% or something of our genetics. I mean, I'm 98%, 98.6. I am 98 point. I know 98.6 is our body temperature, but it's also like 98.6 is the genetic relationship between me and a chimpanzee. We're 98% the same. Somebody might say, well, that's proof of evolution. No, it's not. Why does a car look like a truck? They both have four wheels. That's because they had the same creator. If it worked in a car, the creator made it work in a truck. So, it could be proof of evolution, but it could also be proof of a creator. So sometimes we just need a paradigm shift and think about things a little bit differently. And so the differences between us are cultural. They're not genetic.
Exactly.
And so when we can get past the cultural differences, then we will find we have a lot more in common than we think we do.
That's right.
And the same is true with dogs. All dogs come from the wolf. It doesn't matter if it's a teacup poodle or if it's a Great Dane. Now, here's what's funny. Earlier I said the definition of a species is an organism that can reproduce viable offspring that can also reproduce. A Great Dane and a teacup poodle, they're going to have a hard time reproducing. But it's possible. You could collect semen from, it doesn't have to happen naturally. And this is where evolutions like to do the bait and switch. Adaptation is change within a species over time. Evolution is change of the species over time. Sounds like the same thing, but it's not. The difference is within versus of. So humans changing to become different races because they live in different environments is not evolution. It's adaptation. We adapted to different environments, but we're still the same.
Good point. Yeah.
We're just adapted to different environments, but we're still the same.
Yeah.
Evolution is when one becomes something different. It can no longer reproduce with the original because they're different. They're different chromosomes and different traits, different genes. They're different. So they don't match during fertilization. But see, the teacup poodle and the Great Dane, even though they physically, mechanically are separated, we can, through artificial insemination, we can collect semen from the Chihuahua and inseminate a female Great Dane, and she will have puppies, and those puppies will be able to reproduce with the Great Dane or the poodle. So that means the Great Dane and the poodle is still the same species, but
Right.
it's a breed. So a breed and a race, they're synonyms. It's the same thing. Breeds are illusions. They're populations or families that have been selected to display certain traits that have been chosen by a breed standard or a breeder.
Right. So Lee, this kind of off dogs, but I just want to ask you this because
Yeah.
this is my quirky little mind. In your genetic studies, has there ever been a different form of man, of man, like say we are Homo sapiens, uh,
Yeah.
and if so, how many different type of men was it?
Well, there's a bunch. We can go back to, have you ever heard of Lucy,
Yeah,
the Australopithecus?
right.
Right. You ever heard of that song, Lucy in the Sky with Diamonds?
No.
Okay. Well, was that the Beatles, Wendy?
I like
Yeah,
the beat.
I think it was the Beatles.
Okay.
Lucy in the Sky with Diamonds. Um, they were kind of an atheistic group. You ever heard of that song? Imagine all the people.
People,
All right,
give me.
that's is that who was that sang that song?
That's the Beatles as well, I
I don't think
believe.
it was the Beatles. I think it was the main singer in the Beatles.
It was either Paul McCartney. It wasn't John Lennon, was it?
I don't know, but it was one of them when they maybe
Paul
John, I don't
McCartney.
know. Yeah, it was one of the Beatles guys when he got on his own.
Yeah.
Well, the Beatles was kind of like a atheistic type group, and
Hmm.
if you listen to that song, it sounds like a great song. Imagine. Listen to what they say in that song. It is not a good song. Imagine all the people with no religion, no. A lot of the things they say are very atheistic. Living life however they choose or whatever. I don't remember the words, but if you
Hmm.
listen to it, it sounds good. It sounds good when you're not paying attention, but if you pay attention, you're like, wait a minute here. Imagine all the no God, no religion. Uh, but anyway, the Lucy in the Sky with Diamonds was referring to Australopithecus. It was the idea that we came from cavemen.
Right.
And you have the Australopithecus afarensis and the Australopithecus africanus, and then these led to the hominids. And the hominids, at one time the robustus was a hominid, Homo, but I think it became an Australopithecus here recently. But I may be incorrect to that. So I'll say Homo robustus, and you have Homo erectus and Homo habilis. Habilis meant handyman. So
Mm.
the Homo habilis was the first mankind, according to caveman beliefs, to invent the tool. And then that's why he was called the handyman. Homo habilis meant handyman. And then you have Homo erectus, which is the first man that stood upright. Well, the difference between Australopithecus and Homo erectus is very drastic. The Australopithecus is very much like a chimpanzee or a bonobos ape. You ever heard of a bonobos ape?
Yeah, I've heard of Butterflies. Yeah.
Yeah, they're very much like chimpanzees, but they're more socially behaved, like more like people. And
Okay.
then so Homo erectus is the erect man. They invented the use of fire, and it's believed that they also invented religion because
Really?
that's the first group of people that buried their dead with flowers. Now, why would you put flowers on the dead? Well, it's because you're paying respect. Why would you pay respect to the dead if there was no afterlife? It wouldn't matter. They wouldn't know it. So if you're paying respect to the dead, it's like saying I love you under the belief that they can somehow recognize that. Well, that would be the formation of religious beliefs. And then you have Cro-Magnon man and Neanderthal man. A lot of people think it's Neanderthal, but the H is silent. It's Neanderthal. And then Neanderthal man and Cro-Magnon man and Homo sapien. Some people say they're all the same species as Homo sapien. Um, that they're just integrated into different populations, and they weren't really shouldn't have been separated anyway. But every scientist wants to be famous. Every scientist wants to be recognized as great. So I think some of this levels of taxonomy are falsified. In fact, when I was a kid, like 10, 15 years old, the dog was not Canis lupus familiaris. The dog, and this is another deception in science, the dog back then, if you look it up, find you an old textbook, like 1980, 1970, and look up the scientific name. You're not going to find it online because the online is going to be the modern stuff. But go find you a textbook from 1970 or 1980, and you'll find the dog's scientific name was Canis domesticus, which meant domesticated canine.
Right.
All right. Then atheists liked that because they could say, well, look, we've evolved the dog into a different species. It's no longer a wolf. It's its own species, domesticus. It's not see, on the paper, it says the wolf is Canis lupus and the dog is Canis domesticus. So since it's a different species, that proves evolution. No, it doesn't. That's proof of your fraudulent deception because the dog can still breed with the wolf.
Yeah.
So since the dog can breed with the wolf and have viable offspring that can still breed with the wolves or the dogs, they're still the same species. So it should not be a separate species. So the scientists were forced by the creationists to change the name of the dog. And they changed it, but they did it incorrectly. They didn't want to do it. So they changed it from Canis domesticus to Canis familiaris. And they're like, so it's still a different species because the wolf is Canis lupus and the dog is Canis familiaris. And they're like, no, it's not a different species. So they were forced again by the creationist scientists to push the evolutionists to properly name it. And so now the dog is Canis lupus familiaris, which means familiaris means the familiar wolf.
So did I hear you correctly? I think you said that these different type of men. We don't went into another thing, but I just had to ask you this because I got you here.
It's all good.
They integrated into the Homo sapien, or did they die off?
Integrated, but that's only the three types: Neanderthal, Cro-Magnon, and modern man. But all three of those are Homo sapien. They're the same species.
Gotcha.
So since they're the same species, they shouldn't have been classified separately anyway. And this is only talking on this topic from an evolutionary perspective. My personal belief is Adam and Eve. I don't really get into the evolution thing. I don't believe I come from a monkey. I shared a joke here not long ago where a man was talking to his daughter, and the daughter said, "Where do we come from?" And the man said, "Well, Adam and Eve had kids, and then their kids had kids." And then the daughter goes and asks the wife, "Mom, where did we come from?" And she said, "Well, we evolved from apes and monkeys." And then the kid goes back to the dad and said, "Mom said we evolved from apes and monkeys." And the dad says to the kid, she's talking about her side of the family.
Right. Yeah, and this is the thing about that. This is the thing about that too. If we evolved from apes and monkeys, then why we still got apes and monkeys?
Yeah.
Why the rest of them didn't evolve?
I'll play devil's advocate on that one.
Okay.
Now,
we're gonna get in trouble tonight, Lee.
Yeah. You ever heard of what's called divergent evolution?
Yes, I've heard of it. Yeah.
All right. Divergent means you have an ancestor and it split apart and became two different things. Well, that can happen. You can have one ancestor become different. So it would be possible that if we came from apes, that the apes are here and we are here. And an example I will use for that is not evolution, but this is adaptation again because it's the dog. But if we look at the American Pit Bull Terrier, game bred American Pit Bull Terrier, and the AKC Amstaff, go back 100 years ago, and you'll find a guy named Leitner. And Leitner was, he had some dogs that were registered, and the AKC was founding and coming up with their organization and whatnot. And they had blue dogs and they had red-nosed dogs. And the AKC decided to not accept the red-nosed dogs, but they did accept the blue-nosed dogs. And so slowly over time, the AKC became more of a show line, while the ADBA and back then the UKC was a working dog registry, but in the 70s the UKC lost their way and became a show dog registry as well. But the ADBA still is primarily you're going to be your working dog registry for the American Pit Bull Terrier, and then there's other registries as well, like the Sporting Dog Registry or Bonafide, etc. But I'm derailing. So the two dogs families, the American Staffordshire Terrier and the American Pit Bull Terrier, they did have a common ancestor, but they both still exist today. But they exist today in different niches. A niche is a job or a role or an area. So you could still have both today, but they'd have to live in basically different areas because they lived in the same area. One would surpass and beat the other.
Yeah.
But that's how that could happen.
Right.
However, the reason why I'm okay with Adam and Eve is if everybody believes in miracles, okay? And you might say, well, no, an atheist doesn't believe in a miracle. Yes, they do. They believe we came from a rock. That's a miracle. Okay, a miracle is something that is supernatural. It's not natural for a rock to become a human being. You're like, well, it didn't happen like that. You had millions of years. Okay, yeah. Okay, so now the miracle is still a rock becoming a human being if you give it time. All right, so there's still a miracle there. The question is, what's more likely, the miracle of a rock becoming a human or a God creating a human? I believe that a God created human. I don't believe we come from apes. And on that note, you might say, well, how did you populate the planet? This is where genetic disease comes into play. If there is a creator, a perfect creator, then the first people that he created would have been disease free. Inbreeding is not a problem if you don't have disease. Zero. You cannot have recessive genes show up if they don't exist. But the wage of sin is death. And it says biblically that our sins will be passed on to our children's children's children. Well, when we sin, we get cancers and genetic disease, and we pass those on to our kids. Now inbreeding is a problem.
Gotcha.
And so we're taught that it's gross because we want to avoid it. But if we were pure and disease-free, it wouldn't even matter.
Yeah. Let me ask you let me go a little further in that right there where you at. How does inbreeding and outcrossing influence genetic drift and gene flow respectively? And then why you thinking on that? Please talk about when people say, well, when you bring that cross in, you're just undoing everything.
Yeah. So we already did this particular thing about the gene flow and the genetic drift through the inbreeding and outcrossing. So outcrossing is going to be gene flow. Inbreeding is just inbreeding unless you're selecting. So when you're inbreeding, you might get crap or you might get great. And what's going to differentiate that is not the inbreeding. The inbreeding doesn't make something good or bad. The inbreeding just makes it consistent. And the selection is going to make it good or bad. So if you're selecting the good, you're going to get good. If you're not selecting the good, you're going to get whatever happens. So that's that topic. The second part of your question, remind me that.
It was about the crossing, and when people said that when you cross, you just undid all the work you've been doing because you added in new genes and shuffled the cards basically.
All right. I think people live in fantasy land. I'm not trying to be disrespectful here, but let's just be real and look at nature. Nature, whether evolution or creation, it doesn't matter. We know that animals compete to survive. Natural selection is a fact. I'm not saying evolution is a fact, but natural selection is a fact. If a gazelle is running from a lion and gets away, it passes the test. If another gazelle, related or not, runs away from that lion and gets caught, it does not pass the test. What's left at the end of the day is the ones that pass the test. Now, if you're trying to produce, the best animal to your standard, what is the test in your standard? Do you have a test or is it just cosmetic? If you have a cosmetic thing, then what's the point of your line? What's the point? I believe that a dog should benefit my family. It's not a piece of art. It is a companion, a guardian, and a hunter. Just like in caveman days, if cavemen existed. The reason the dog was domesticated is because it was a companion, it was a guardian, and it was a hunter. And that's what my dog is. So my test is it a stable companion? Is it a good guardian? And is it a good hunter? Which means it has to be a good fighter. Because you don't successfully hunt without gladiator combative skills.
Right.
You have to have those things, and you have to be able to work in multiple terrain. So if a person says, "Well, an outcross just undid it," You don't outcross because you want to outcross. You outcross when you want to bring something in to take your population to make it better as a companion, a hunter, and protector. You're trying to improve the line. Now, somebody might say, well, that means your dogs didn't have what it meant. There's no such thing as a perfect dog. There's no such thing as a perfect line. Anybody that tells you that they have a perfect dog or a perfect line is delusional. There's no such thing. Perfection does not exist. Go read Charles Darwin, an evolutionary guy, and you'll find that people that talk about the reason evolution, if you believe in it, always occurs is because the environment is always changing. And even if the environment didn't change, it still changes because the competition changed, because the competition's trying to get better to the environment. And as that competition gets better, now you have more competition. So you have to get better too. And so there's no such thing as perfection. It's always faster, always stronger, always better endurance, always more disease, whatever disease resistant. Something new is going to come along like COVID. And then you're going to have to struggle with that. And so there's no such thing as a perfect organism. So the person that says that you should only line breed or only inbreed, what's the measure? When the environment changes and you suck hind tit and somebody else outperforms you, are you going to outcross if you need to? Or are you going to say, well, let me just throw all my work away and start with another line? Well, that line is going to meet its limit too. There's always going to be a limit. So every line has a limit. So there's a time to outcross. And that's, again, the American Sentinel is a band dog, which is a cross between them. Or the band dog is a dog bred to catch man or beast. But the Sentinel is a type of band dog that originates from the game bred American Pit Bull Terrier, the English Mastiff, the Neapolitan Mastiff, and the Tosa Inu. But most of it, we have some dogs that are 90% American Pit Bull Terrier. We have some that are, maybe only 50%, but most of them are going to be around 65 to 75% American Pit Bull Terrier. But that's because the American Pit Bull Terrier is not perfect. We outcrossed the Mastiff traits to bring in some desirable traits. If you are so hung up in the love of your pedigree and your standard that you will not allow outside blood into your program when that outside blood has some feature better than what you have in your population, then you're being prejudiced, you're being biased, you're being closed-minded, small-minded, and small-minded over the test of time loses. There's no doubt in my mind that America's the strongest country in the world because we are an integrated population.
Gotcha.
Now, there may be isolations that different groups can specialize and become better at different things, but as a whole, there's a time and place for both. You purify a line on a trait when you have a line that's doing really well, and when you reach the limit, you don't be afraid to outcross. And the limit may be a reduction in health, it may be a reduction in litter size, or it may be some sort of trait that's lacking. And somebody might say, well, you need to just test those or select those individuals more rapidly. Remember, humans cannot get away with line breeding or inbreeding because we have one kid a year at most. Well, you might have twins or triplets, but those are anomalies. That's not normal. The norm is one kid a year at most. And you might have, let's say you're just a big family person, you might have 10 kids. That's not very many offspring. Dogs have not 10 kids in their life. They have 10 kids in one litter. Okay. And they can do twice a year. They can literally have 20 puppies in a year. But that might still sound a lot until you look at something else, like fish or birds. Chickens lay 200 eggs in a row. 200 eggs, and one egg a day for 200 days. And fish have 200 eggs at one day. And then next month they can do it again if they're in domesticated environments. So the more you reproduce, the more you can get away with inbreeding. Because when you inbreed, you're going to cause the detrimental traits. You're going to have the good show up more and the bad show up more. But because of the bigger the population, the more you can cull. And the more you can cull, the more you can inbreed. But when you have a small population, if you have one kid a year, you can't cull your kid. You can't do that. You're like, well, that one's messed up, I'm going to cull him. No, you can't take that risk. You have to outcross because we have disease in our population. So the odds of us pairing up with another individual that carries the same disease as us is pretty low unless we were to reproduce within the family. If you reproduce in the family, then you're going to have that same disease show up and you're going to get messed up kids because we carry a lot of disease.
Right.
But with dogs, you can filter that out more with dogs than you can with people. And with chickens or fish, you can filter it out even more because they have more babies. You can afford to cull 90% of your chickens or 95% of your fish. You can't afford to cull 90% of your dogs. You might be able to afford to cull. When I'm talking about cull, I mean right off the bat.
Oh, cool. Yeah.
I mean,
Yeah.
hard cull.
Yeah. With chickens, you can eat them. You can do all,
Yeah, exactly. But dogs, you need to work on that better half of the population. Well, let's say if you can, we have to look at a term called carrying capacity. The carrying capacity is the more you can carry, the more you can select. If you can only house 10 dogs, it's going to be difficult for you to be a great breeder. You can do it if you can collaborate with other people that have 10 dogs apiece. You got 10 people with 10 dogs, that's 100 dogs. Now you can get somewhere.
Yeah.
And this is why the American Sentinel program, people look at my program and are like, man, you got 30 dogs? That's a lot of dogs. You're right, it is a lot of dogs, but it's what's necessary to drive this program's evolution or adaptation over time. If I only had 2 dogs, where would I be in 20 years? Or 5 dogs, where would I be in 20 years? I could not cull anything.
Right.
If I only have 1 litter every 2 years, I can't cull anything. I got to keep them all. And I mean, I can cull them in 2 years and have 1 dog.
Yeah.
But you're not going to really drive evolution with that. But if you have, let's say, 300 birds or 3,000 fish, something that is very easy to care for because you have a chicken farm or a fish farm and they don't cost a lot of money to keep and you don't have to worry about them destroying facilities or biting your neighbors or something like that, then it's a low cost of investment. Those organisms, if they have a high reproductive rate, then there's a low cost of investment. And when you have a low cost of investment, you can afford to cull harder. With dogs, you can't inbreed dogs as much as you can chickens or fish. Even if you mathematically can, you have to think about sustaining the population. And with sustaining the population, you have to make sure that there's enough individuals in the population that do not carry detrimental traits. Now, you can push it with like mice. Now, with mice and rats, these are mammals, and they follow the same principles as dogs in terms of genetics, but there's even a difference here. Mice can reproduce every 21 to 28 days. Dogs can't do that.
Yeah.
And mice, I could have 1,000 of them in my house if I was breeding mice for whatever, for snakes or for a lab or something like that. You could breed 1,000 mice and keep them in a garage. You could have 1,000 mice in bins. You can't do that with dogs. And 1,000 mice, what would it cost? $200 a month. I spend $2,000 a month on dog food.
Yeah.
And I don't have 1,000 dogs. I got 30, and I spend $2,000 a month on dog food. So it's not practical to inbreed as much because when you inbreed, there's a time and place for it. And some people might say, just bite the bullet and push through. Yeah, with a 90% death rate. Now, I don't get me wrong, I'm blessed. The biggest problem with the American Sentinel is probably going to be hip dysplasia. And hip dysplasia probably is 2%. Maybe if I had 100 dogs, I might have 2 with hip dysplasia. That is so rare.
That's good.
That is ridiculously good.
Yeah.
You go look in the world of Mastiff pit bull type dogs, you're going to find 2% in pit bulls. You're going to find 5%. I mean, it's there. That's the biggest problem, but it's rare. The average Mastiff is probably like 50% hip dysplasia in some Mastiff breeds. Some Mastiff breeds.
Yeah.
And so getting to 2% means my selection criteria has been very, very good because that's like anomaly percentage. Very rare.
That's very good. Yeah.
But my point is disease is there. And with chickens or fish, you can push the envelope because if they get the disease, who cares? You can eat it.
Right. Easy to discard. Meiosis, and why is it significant in the context of genetics? And I know you're gonna do a show on this, but we just tap on it for a little bit.
Sure. Well, and remember the E is silent, so it's
Okay,
meiosis.
meiosis. Yeah.
Yep. The most people say meiosis.
Yeah.
I've known professors and teachers that say meiosis, but it's meiosis.
Okay.
But anyway, so imagine that we went and bought a deck of cards, and all the cards in there in your deck. We both bought a deck of cards. We both have the same cards. We both have 4 aces, 4 twos, 4 etc. All the kings and queens and everything. But let's say your deck of cards on the off side, the back side is red, and the back side of mine is blue. So let's say that one deck of cards is going to represent the alleles from one parent, and the other deck of cards is going to represent the alleles or traits from the other parent. Well, when we mix them together, if we just put them together, and obviously we're talking about cards or dogs here, and we separate them, you can get puppy, offspring, puppy, offspring, puppy, offspring, puppy, or puppy, adult, offspring, puppy. You can repeat it over and over, but then they're still red and on one side and black or blue on the other. But that's not the way it works. In meiosis, what happens is an event called crossing over, where the cards will trade sides. Some of them will trade and some of them won't. So when we separate, you're still going to have a complete deck of cards, and I'll still have a complete deck of cards. But now I might have some red ones, and I might have some blue ones, and you might have some red ones, and you might have some blue ones. And then the next time those cards are shuffled and shuffled and dealt and shuffled and dealt and shuffled and dealt, because that's what happens. Sexual reproduction means, I mean, think about this for a minute. It's kind of strange.
Mm-hmm.
Can you imagine taking a needle out of one organism and stabbing another organism and injecting DNA into it and making a different set of DNA? Sounds strange, doesn't it?
Yeah, sounds weird. Yeah, very weird.
It's not. That's what a penis is. It injects.
Yeah, thank you.
It injects.
Yeah.
They're trading DNA. And so by exchanging the DNA, you have the egg from the mother, and the DNA delivers the sperm. He's literally injecting his DNA, but it's different combinations. The whole purpose of sex is to create a new combination, and that happens because of meiosis. Meiosis is when those genes mix, and now, even if they have 100 kids, none of those kids have the same DNA unless they were twins. And if they were twins, that means they were actually one individual. You know what the difference is between a Siamese twin and an identical twin? So you have paternal twins, which is when it's 2 separate eggs and 2 separate sperm. They're just brothers and sisters.
Mm-hmm.
But you also have identical. Identical twins and Siamese twins is the same thing.
Oh, okay.
It's just one of them separated and the other one didn't.
Yeah.
Identical twins used to be one person.
Wow. Okay.
A lot of people don't know that.
Yeah.
So they are a clone. One is a clone of the other. They literally were one person if you go really early in the development.
Uh-huh.
So what was that question? Why did I bring that up? I lost my train of thought.
Well, yeah, I asked you, what did I ask you? Meiosis. I got it right this time. I said I was asking you why is it significant in the context of genetics, and I think you nailed that one.
Yeah. So it's what it does is it increases genetic variation.
Right.
So
right.
let's look at sexual reproduction versus asexual reproduction. Asexual reproduction means they're going to reproduce without having sex. So bacteria do not have sex. Bacteria in mitochondria in your cells, the mitochondria in your cells, they're like bacteria. They do not have sex. The mitochondria clone one another. Now, this is also something that is kind of a misnomer or misconception or deception or whatever you want to call it in dog genetics and human genetics. While it's true that the egg gets the mitochondrial DNA from the mother doesn't just have one set of mitochondrial DNA. One cell could have 1,000, maybe even 10,000, and there's even a few cases where it's hundreds of thousands of mitochondria. Now, out of those 10,000 mitochondria that are in there, about 90% of them are identical. The other 10% are difference.
Mm-hmm.
And that's because in the cell there's competition. And those mitochondria are overproducing, there's variation, they're competing, and the winners reproduce. And 90% of them are the winners. But you have 10% that are still surviving. And so all of your mitochondria came from your mother, but your mother didn't just have one type of mitochondria, she had a multitude. And so it is theoretically possible that you could test your mitochondrial DNA and test your mother's mitochondrial DNA and it'd be different, not because you didn't get hers, you did get hers, but they may have gotten one of your 10% and one of her 90%, or vice versa. And so asexual reproduction is very fast, and that's the benefit. You don't have to waste time taking a girl out on a date. You don't have to buy her dinner.
Mm-hmm.
You don't have to find the right person. You just reproduce on your own.
Yeah.
Boom.
Yeah.
No courting, no courtship, no evaluating the prospect. See, sex is risky business. You're going to mix your DNA with somebody else.
Mm-hmm.
You better know what you're dealing with. You got to get to know that person, see if they're worthy.
Yeah.
Because you're going to literally have a child with this person potentially. And so with sexual reproduction, you're very selective about who you're going to mix your DNA with. And that's because it's going to create a new combination, but it's also slow. So with asexual reproduction, it's very rapid, but they're all the same. And with sexual reproduction, it's the opposite. It's very slow, but they're all different. So what's the benefit of being all the same? There is no benefit of being all the same, but there is a benefit in being rapid, because if you're rapid, you can build a big population very quickly. And because of the numbers, the odds are some will survive. But with variation, sexual reproduction, the numbers are low, but because they're different, you don't have all your eggs in one basket. So that means, that's where that phrase comes from. By having all your eggs not in one basket, if you drop that basket or a tough environment happens, maybe somebody has the right trait for that environment.
Right. Okay. Well said. Well said. I want to go into common mistakes in learning genetics. Why should people be skeptical? Oh my God. Skeptical of relying solely on formulas for breeding. You've been tapping on this all night.
Yeah.
Yeah.
Well, people like to buy snake oil. Mm-hmm. And genetics is a topic that not everybody knows. And so somebody comes along and they're selling the idea of genetic education, and people want to jump into that, and they think they have a secret formula. It's like exercise. Every time, if you want to get in shape, you start studying every fitness program, every diet program.
Yeah. Yeah.
Come on, y'all, just eat right. I have not eaten at McDonald's in like 6 months, and I had McDonald's tonight. But you and I both know you don't have to have the perfect exercise program and the perfect diet program, but we both know you shouldn't be eating McDonald's, and we both know you need to exercise. Yes. So while having the best exercise program and the best nutrition is certainly an advantage, mm-hmm. The problem is with the internet, you have a lot of people that are educators that really are not worthy educators because they don't have the proof of concept in a field that's applicable to dog breeders or dog. When I say dog breeders, there's two aspects to consider. One is the dog, two is the person. Mm-hmm. If the person cannot keep 30 dogs, then selection matters more. And even if they can keep 30 dogs, selection still matters more. So, because dogs, you can't just have 1,000 and cull. You have to. Selection really matters. Selection matters more than breeding, because you can buy a dog anywhere in the world today and get it shipped to your house. So there's no reason to buy a dog that's substandard.
No, yeah, you're right. You're exactly right. Yeah.
And if you just want something free or local, you ever heard that statement? You got $1 million desires, but $10 work ethic.
Oh yeah, for sure.
Yeah. And so that's the biggest problem is a lot of people they want to sound like a pro. And I'm not talking about just the people on YouTube selling stuff. I'm talking about the people on Facebook groups giving advice, or people saying, I understand genetics and look at the genetics of my XYZ dog that can do XYZ thing. And the reason it does it is because I'm a great geneticist, but they can't even use a Punnett square. They think a Punnett square is 4 generations. Punnett square has nothing to do with generations. So trying, it's sound bites. It's secret formulas and secret recipes. It's important to be able to communicate with your peers. But if you don't know the words, then you're not ready to communicate with the peers. You need to go study these words before you do it. And, I would spend my time, if I did not understand genetics, I'd want to learn genetics. And I think it would be good to learn genetics, and I'm not saying it doesn't matter. Obviously, I've said over and over again that genetics matters and understanding it matters, but selection matters more, and the people you work with matter more, and understanding animal behavior matters more, and performance testing matters more, and having cooperative people that you can work with that aren't going to try to cheat you when things go not to your advantage or go and not to their advantage. People need to collaborate and work together. This matters more. Being a man of character or a woman of character matters more. Because with dogs, if you can, the days of kings having 100 dogs are over. I know one guy today that has 290 dogs.
Wow.
Yeah. That's not doing that in the United States. He's not.
I was about to say he's not here.
No, those days are over.
Yes,
so
sir.
You have to have a team of people. I work 80 hours a week with 30 dogs. 80 hours a week.
I bet.
Yep.
Yeah. Do a dog shit all day long.
So that genetics matters. The question was, what was the question? Tell me the question.
I was just we was on common mistakes in learning genetics, and I asked, why should people be skeptical? I can't say this word today, or of relying solely on formulas for breedings.
Yeah, well, it's mainly because 2 dogs can have the same formula. They can have the same number, but still be totally different value. So selection matters. Now, the other thing is, I said it's important to talk to peers. There are some people that are, like, I know one guy in a Facebook group that talks about selecting for desirable traits. He's always talking about selecting for desirable traits, and that's another thing you got to be careful for. Even though selection for desirable traits is the thing you should actually do, he doesn't do it. He's never worked a dog a day in his life. And so all of his successful dogs and accomplished dogs are dogs that he purchased from someone else. So how can you say that you're selecting for desirable traits when you're breeding 3 and 4 generations of your own stock, but the only dogs that you've ever advertised that have done anything were dogs that you bought?
Oh, wow. Yeah.
Yeah.
Makes sense. Let me ask you this. It's an uptick. I almost called it some months back. It's an uptick on dog breeding programs. All you got to do is Google now, dog breeding. Everybody's dog, because it's a big money market, and that mentorship is a big money market, especially if you can put it online, wrap it up in a website, or however you do it. Is there? I know genetics make change, but is there any new form of breeding techniques or strategies?
No,
I'm sure
everybody. There's a lot of people out there that are saying that I can give you advice on how to. I saw one guy the same guy that was talking about the Punnett squares, saying it was 4 generations, was talking about pattern breeding, and he was saying you can recognize a pattern. You cannot follow a pattern, y'all. We can see patterns in pedigrees, but pattern breeding. Am I still there?
You here? Yeah, I see you.
Okay. Yeah. The pattern breeding places emphasis on a pattern, and that's the fastest way to destroy a population. You don't want to breed on a pattern. You want to breed on selection. Now, if you have the right individuals and you're selecting for traits, select for traits, breed for traits. Remember, that's what nature does. Nature says, can the gazelle outrun the lion, or can the lion outrun the gazelle? That's what matters. These are the traits. And guess what? Nature produced homozygosity without massive inbreeding. Inbreeding happens in nature, but it's not massive. Do you think crickets are only breeding with the related crickets? They're all over the place.
Right.
Yet they're all black and they all live by the dirt. Grasshoppers, or they're all green, and there's some brown grasshoppers, I guess, but you get my point.
Right.
The birds are flying all over the place, and yet they all look the toucan all looks like a toucan. They're not just breeding with their relatives. Nature has produced homozygosity not only by inbreeding but also by selective pressure. So if you're selecting for size, you're going to get homozygosity eventually with size. All inbreeding does is accelerate the process.
Right. Right.
So
So
you can accelerate it good if you're selecting wisely, but you can also accelerate to destruction if you're not selecting wisely.
yeah, you need help with that. Yeah. A lot of guys look at my channel and they hear things, and I'm like, dude,
Look at
chill.
look at the breeding that Patrick did, and Floyd Boudreaux. They've been breeding pit bulls for Patrick bred pit bulls for 40 years. Floyd Boudreaux still alive, still has population of dogs today. Bred dogs for 50 years, more than 50 years, because he's like 90 years old now, and he was breeding dogs when he was in his 20s or 30s. So 60, 70 years. These guys, you can see these patterns that are being sold. I believe in collaborating with my peers. I told you that I spoke with people from Princeton. I spoke with people from Cornell. I spoke with a professor from Harvard. I spoke with a professor from the University of Illinois. None of these individuals make me sign a non-disclosure agreement or something. Look, professionals don't do that. Professionals do not have some snake oil secret recipe that they're trying to sell to somebody, because they know everything that's being done has been done before. The only thing that we should charge for, in my opinion, is being a teacher or a mentor. But it's, if I teach you something or you teach me something, that's just being a teacher and a student. There's nothing in genetics as far as breeding that is a secret. There's no secret formula. It's just still the male's penis goes in the female's, and you're going to have puppies.
Yeah,
That's all there is to it. And
Yeah.
you can do inbreeding, you can do outcrossing, and really true geneticists don't even use the word line breeding. They use the word inbreeding or outcrossing. Line breeding in the canine world, it's considered something like cousins, uncle, niece, aunt, nephew,
Right.
second cousins, half siblings. These would be line breeding methods. Grandparent to grandchild, those are all line breeding methods. But in a geneticist world, those are all just weaker inbreeding. Inbreeding is basically breeding related individuals.
Yeah.
Outcrossing is breeding individuals that they either have no relationship at all, or the relationship is so small it's equivalent to the normal population that's not related.
Gotcha.
So like by the time you get to fourth cousin, you're no more related than the average stranger down the street. I mean, it's fourth cousin is very weak. I'm 50% related to my mom and dad. I'm also 50% related to my brothers and sisters. I'm only 25% related to a half sibling. I'm 12.5% related to a cousin. I'm 25% related to an aunt or an uncle. I'm 6.25% related to a first cousin once removed, 3% related to a second cousin, 1.5% related to a second cousin once removed, less than 1%, about 0.75% related to a third cousin. So if you're doing third cousins and you're talking that line breeding, 0.75%, are you kidding me? That's nothing. That's less than 1%.
Right.
So that's not line breeding. That's just selection is what it is.
Yeah. Man, they up in the morning over there in Cape Town, Africa, listening to you. It's 5:46 a.m. where they are.
Yeah.
Yeah, we appreciate y'all coming. We getting near the end here. I got two.
This is a long podcast, but we've covered
Yeah.
a lot of content,
Yeah.
and I would recommend that your viewers come back and watch this content little by
Yeah.
little, save where they are, come back and watch it again, because
It's study
there's some good
material.
stuff. In my opinion, there's some good stuff in here.
Yeah.
But maybe I'm being narcissistic. I don't want to be narcissistic.
Oh, no,
Look, I'm
no.
not a god. Nobody knows it all.
Right.
But if we shared what we know with each other, we can become a better team.
Oh yeah. But I'm gonna address this out for them too in the description, so they'll know, like almost like in chapter form, so they can navigate it. Why is it important to analyze historical pedigrees when understanding breeding practices?
Well, then you can see that there's no secrets. Anything that somebody's like, when I see these people today in these Facebook, there's one guy that writes 5 pages at a time, and he'll put his pedigrees throughout his posts and talk about the methods that he uses, and everybody uses these methods. It's nothing unique. The question is, did you select wisely or not? And I'm going to refer back to Pat Patrick. He is behind more lines of working dogs than probably any dog breeder in the world. And you might think that that's a bold statement, and it is, but he is. The man had like 200 dogs, 100 to 200 dogs for 40 years.
Wow.
He is behind, like you've heard of Mayday. He's behind Mayday. He's Buck. He's behind Buck. He is behind so many different lines. Boyles. He's behind Boyle. I mean, the man produced a lot of dogs. And what he basically did is he dealt with the Bolio line. He dealt with the Tombstone line. He had a Tater Faith dog. He had these three basic, and Tater Faith was actually 2 different dogs. So you could say 4 or 3. I don't know how closely related Tater and Faith were, but from those 3 combinations, the Tater Faith, we're going to call that 1, even though it's 2 dogs, Bolio and Tombstone. And then obviously he had a bunch of dogs that were not of those, but those are his foundation dogs. You can find pedigrees that he took, like Bolio was his favorite dog of all time. He would take Bolio and breed it to a bitch from one of those other 2 lines. Then after he got the offspring, he'd take a bitch out of that and take it back to Bolio again. So now he has a 3/4 Bolio. But he may have a 3/4 Bolio with a Tater Faith, and he may also have a 3/4 Bolio with a Tombstone. And then he may also have a 3/4 Bolio with some other line. And then he would breed those opposite lines, like the Tater Faith Bolio bred dog with the Tombstone Bolio bred dog. And he would try to keep that 3/4. But the reason you can't just copy that method is he did one other thing. He tested all of his dogs. And if you don't do that testing, you just got math. True. And that doesn't matter.
Right.
So some people might say, well, Pat Patrick wasn't matching a lot of dogs. You're right. He wasn't matching a lot of dogs. He tested them himself because he wanted, that's the world that he was from, and he was interested in those type of dogs. So he tested them in that regard. But you don't have to test. When I'm working a dog in protection work, 9 times out of 10, there's no camera. Now, we're not doing anything illegal here. We're doing protection work and hog hunt.
Exactly.
When you're hog hunting, 95 times out of 100, there's no camera. Man, you're running through briars. You're dealing with a knife in one hand, a dog in a situation in another hand. You're wanting to make sure your dog catches that hog, that the dog's not dangerous to you. Your dog doesn't get injured. If there are any injuries, you got to deal with that. It can happen. So I got distracted because these dogs are playing in front of me, cutting up.
Yeah.
So Pat Patrick tested his dogs. He was not just formula breeding. And if you think he was formula breeding, you don't know the man.
Mm-hmm. Mm-hmm. And don't you got interviews with him?
Yeah, I've done interviews with him, but mostly on well, I've got like 1 or 2. Then my friend, we got some interviews with Madison Parker.
Madison Parker, yeah.
I would like to do another interview with Pat Patrick, but he's getting to a point now that his mind is still really sharp, but his body's starting to fail.
Yeah.
a little bit, and because of that, he had a problem with his eye, and he had to get eye surgery for get cataracts removed,
Uh-huh.
and he can't see very good, and he's moving around slower, and so he likes to keep his TV up loud, and so if you're talking to him, you can hear the TV blaring like in the
Oh, yeah.
background,
Yeah. That's
and
how
so
my dad was.
it's getting harder to communicate with him, but it's
Yeah.
still feasible, it's still possible,
Yeah.
and he's still very sharp mentally.
Okay.
Um, and it would be nice to do some interviews. But at one time, you ever heard bitter old man? He's kind of wants to do his thing, and he's not real happy with America because the way they raided his place in 2008.
Yeah.
He served our country. He
Yeah.
was a military.
I listened to that story. They
Yeah,
didn't
he
give
was
it
a
all
military.
back or nothing.
Man, they raided his property like SWAT, drove over his fences with armored vehicles, came in there like he was some massive cartel or something.
Yeah.
And he was like standing there. He's like, "Man, y'all didn't have to destroy my property. You could have called me and said you had arrest. I'd have drove up to the police station and turned
Yeah.
myself in." I mean,
Right.
because he's not a criminal.
Yeah.
And they went to court. He was found innocent. And even though he was found innocent, or found, excuse me, not guilty, technically,
Not
they
guilty.
don't find you innocent. They just find you guilty or not guilty. He was found not guilty, and they euthanized all his dogs anyway. And
Yeah.
then to cover his defense, because he didn't have an attorney, he had a county prosecutor or defense county assigned attorney or whatever it was. I don't
Yeah.
know how it
We
worked
call
out.
them public pretenders.
Yeah, yeah, public defenders. That's right.
Yeah.
And pretenders. He had to pay something, and I don't know what he had to pay, because public defender you shouldn't have to pay, but somehow they had. Oh, I know what it was. He didn't have to pay for the court, but he had to pay for the keep of his dogs while he was in court, which is
Oh,
crazy because
yeah.
that's punitive damages that he was not even guilty of.
Mm-hmm.
And so they euthanized all his dogs, and then he had to pay for that.
God.
And after he paid, so he signed a piece of paper where he agreed to let the court take his land to pay the court costs under the agreement that he was going to get whatever was left over after the court costs were paid. Well, the court sold his land to their buddy for the court cost fees, so he got nothing.
So they robbed him, basically.
They robbed him.
God.
And so he became pretty bitter from that experience, and you can't blame him,
Yeah.
because we do have good politicians and good police officers, but we also got some corrupt ones, and there's a lot of them.
Yeah. Especially if you got something we could use that. Boy, it is.
And the politicians are worse than the police officers. Most police officers, I think, are pretty good, but you got some that are criminals, and then the politicians, most are criminals, and you got some that are good.
Yeah. Well, I'll say this about politics. I'm glad the election over. Let's be friends, everybody.
Yeah. And if you don't want to be my friend, just don't step on my toes, and it's all good.
Yeah, exactly. I got one more for you, Lee. How can breeders ensure they place value on proper selection, and what lessons can we learn from nature's processes?
To make sure that they place the right emphasis on proper selection is get to know some people that excel and find out what they do, how do they test, how do they select, and learn from the best. And when you learn from the best and you put those measures up, then you're probably going to be fine in the selection measures, but you got to copy what nature does, and that's performance test. And even though we use hip x-rays, our hip x-rays are not a performance test. So in a way, a hip x-ray is kind of like show breeding, but because it's breeding for structure instead of performance. And the reason why I justify that to some degree is because a dog that has clearly bad hips is not going to perform. Now, you might say, well, here's the anomaly that has such a high pain tolerance that he's still able to perform, which means that's bringing something else to the table with pain tolerance. And you're right. You can make a good point that pain tolerance is a desirable trait. However, you have to balance the cost-gain ratio here. And if the gain of pain tolerance is going to cost you sound structure, then you're still going to have a hard time conditioning that dog and using that dog for longevity, because eventually that dog's just going to be broken down and not able to function. So even though hip x-rays are not really true performance testing, we do that because from a cost gain analysis, I can hip x-ray a dog for much cheaper than most people. Most people do OFA or pin hip. I don't do that. Our veterinarians are he's trained in radiology. He knows how to read an x-ray. So we shoot the x-ray. We don't even use anesthesia, so that saves me money. We put the dog on the table. I'm in the room wearing the protective gear that you wear when you're doing an x-ray, and I'm talking to the dog, and I'm getting the dog to be cool and calm. And then the x-ray is also targeting the radiation just right on the pelvis. It doesn't even leave that area. It's really targeted, and so it's safe. And but I'm not doing any of the x-ray. I'm just talking to the dog, right? It's just like when you go to the vet and you get a rabies shot, you're probably in the room and they give the shot. And so if it was dangerous, I wouldn't be in there. It's not. They've got it set up where it's safe, and I'm just talking to the dog, and I'm like, hey baby. And I do that because it saves me a couple $100 on anesthesia, right? So I'm just, hey buddy, lay down, be good, be good, be good. And we get him in position, and I can tell, because I'm at the head of the dog, I can kind of look down the body, make sure the spine is straight and the legs are straight, because I'm getting my eyes down. From up here, it's hard to tell if my finger's straight, but if I get my eye down and I can kind of gun barrel it and shoot it, and I can see that the position's right, and I'll say, okay, position's right, shoot it. And I'll say, hit it, and they hit it. And they're trying to line it up, but they're struggling with the dog. It's not under anesthesia, and they're trying to hold his legs there, and we'll get him to calm down. And I can feel his body, and feel her body, he relaxes his muscles, and he's straight. And I can also tell the dog's paying attention to me, and he's like calm. He's not happy and wiggling, so it's going to be a shoot. And I'll say, shoot it, and they tap it, and it's real quick. Boom. And I get an x-ray for like $75.
There you go.
You go some places, sometimes it's $100, but you go to most places, you can't get an x-ray and walk out the door without spending $400.
You're right. You're
and
right.
you might think, well, what's the big difference? 100, 300, 400. Well, when you have 30 dogs, it's a big difference.
Yeah. Especially when they do this. Let's get one more. Just get one more, just in case.
Oh, they don't charge me extra when they do that.
Oh, really? Oh, God.
Yeah, man, they don't use the old film anymore. It's all digital now.
Oh, yeah.
They just hit it again, and boom, we're good.
Yeah, that's what's up.
Yeah, they don't charge me extra. So but a lot of places you do the anesthesia, you do the little great cradle. What is it called? The cradle. They do have a little cradle thing that positions the leg. We just do it manually and get it right and shoot it. And some people might say, well, yours aren't OFA, so it doesn't count. Okay, fine. We put the picture online on our website. You can look at it, and you can show it to your vet, and you don't have to trust me.
Right.
You show it to your vet and let them tell you what they think.
Yep. They can tell you, those hips trash. You know what I mean? They would know. They should be good enough to know that. They do it so much. So
and OFA is just an organization, Orthopedic Foundation of America. All they're going to do is charge you $300 to put their name on it. I don't need their name. They're not out here feeding these dogs, working their dogs. I am. I'm breeding these dogs to make the best dog I can. And if I have some money in my pocket, I can feed them better and work them more. So if I'm broke, I'm feeding my dogs trash, or I have less dogs. So I have to look at what's best for the program as a whole. OFA is not what's best for me. Pin hip's not what's best for me. For me to make the most success, I have to test as many dogs as possible and get the information. I don't need a stamp. I need the information.
That's right.
You don't have to have a PhD to have doctor knowledge. You can. You ever seen that movie Good Will Hunting?
I've heard of it, but I hadn't seen it.
Yeah, it's a good movie. Matt Damon he can do mathematics that the professors at mathematics are not able to do.
Oh, wow.
Because he's self-taught, and I don't, my vet may not work for OFA. He may not work for pin hip, but he's a radiologist. So, I mean, come on, he knows x-rays better than me or you.
That's right. Yeah. And at least you look at them, because, any scientist, if you're a breeder, I kind of figure like you got to have a science mind. You'll want to just know what's going on, but hips trash. And another way that people always tell me, well, because like I said, it's breeders who don't health test. is breeders who don't go through the extent of OFA and pin hemp. But if you get your hands on them, you could check them. You'll check them, and you wondering why they're good. It's because they know their dogs and they work their dogs. You know what I mean?
I sent you a pedigree the other day.
Yeah.
Of a Bolio bred dog,
Uh-huh.
and I saw that it came in my feeds earlier today.
Yeah.
How would I find that if I was looking for it right now? I'm on your channel, but how would I find that picture?
You go to community. You go to my community. Yeah.
All right, I'm on community. I see the videos. I don't see the picture. Oh, here it is.
Yeah.
All right, can I do a screen share and look at this real quick?
Right. Yeah, the community tab is very useful. People don't think people look at it, but they do. Okay, here we go.
All right, so where's the one that shows all the generations? Is this it? Just here? You just got to click on it?
Yeah, click on it. It'll open.
I've never used this community tab, so my apologies.
Oh, yeah.
All right. So this must just be the first. Well, that doesn't show you the whole pedigree.
If you click, I wonder why it's showing it like that.
All right, let me just type in Patrick's Raquel.
Okay. Hit the like button, guys. Hit the like button. Hit the like button. Share. This is a simulcast.
All right. So we're looking at her pedigree here. Look, Indian Bolio, Indian Bolio, Indian Bolio, Indian Bolio. So that means this dog here is 3/4 Bolio, and this dog here is 3/4 Bolio. And when you breed a 3/4 Bolio with a 3/4 Bolio, you still have 3/4 Bolio. So, and look at this. It's interesting. These two dogs are actually siblings because they're both out of Bolio Red Baby. And Red Baby was off of Goldie and Goldie. So this is a really tight breeding. So you have a 3/4 dog to make this dog and a 3/4 dog to make this dog, and they're actually full siblings. So that's a parent. So you have an offspring, and then you have grand offspring, and then you have a brother-sister breeding. So that right there. Some people would call that like a pattern or a formula that you need to follow or copy. Well, that pattern or formula produced this dog. So you have a father-daughter breeding and a father-daughter breeding, and then a full sibling breeding. What he is doing here is he's improving consistency. Yeah. But that does not make a program good. What made Patrick's program good is not only did he improve consistency, he also improved consistency of quality because he tested his dogs. You'll notice it says here, Raquel has an extremely strong bite. So how would he know that if he wasn't tested? He was still testing his dogs. Let's look at another dog that that I sent you on a pedigree. I sent you Chilindrina. I'm not a speller, and that's a weird name.
There it is.
All right. Here we have Bolio and Bolio and Bolio and Red Baby. So Bolio Red Baby. So this is the full sibling breeding right there that produced that dog. And then what's the bottom side? Bolio, Red Baby. So man, this is crazy tight. So you have a Bolio, Indian Bolio, Indian Bolio. So you got a 3/4 dog here and a 3/4 dog here to make this 3/4 dog, and you have, and that 3/4 dog was made from a full sibling breeding, and then you did it again. Patrick's Red Baby, Patrick's Red Baby, Patrick's Red Baby, Patrick's Red Baby, or excuse me, Bolio Red Baby, Bolio Red Baby, Bolio Red Baby, Bolio Red Baby, and Red Baby herself was a daughter of Bolio.
Yeah,
that's crazy.
That is. So, did he tell you why he did it that way?
Because Bolio was his favorite dog of all time. Okay. Bolio was a dog that he was only matched technically twice, but he was OTC, which stands for off the chain, looked at a number of times, and one of the times he went uphill like 5 or 10 pounds, and he was just a dog with great skills, and he felt like being a once in a lifetime dog. He deserved once in a lifetime line breeding.
Gotcha.
That's not something you do with just any dog.
That's
All
right.
right, let's look at another one here. We got. That's the thing. People copy this formula, but they started with trash, and they're like, "Oh, I can just line breed and inbreed on it like Patrick did, and I'll be successful like Patrick." No, you won't, because if you started with dogs in the neighborhood instead of world class animals, you're going to get a bunch of dogs in the neighborhood.
Mm-hmm.
All right. I don't know if that makes sense to you or not.
Yeah, it does. Yeah, it makes a whole bunch of sense. I made a video the other day because I have a lot of young men message me on Instagram, and I said I will always start my program with a female because they give me an option. I said preferably two because sometimes things don't work out. Anything can happen when you're breeding dogs. What are your thoughts? What are you gonna start out a program, Lee? How you gonna do it?
Well, the best way to start a program is to start with the best dog you can get.
Right.
If it's a male, it's a male. If it's a female, it's a female.
Okay.
And in many ways, it's advantageous to have it be a male, because if the best dog you can get, you get it, that dog should be really awesome. The next thing you want to do is breed the hell out of it. Well, you can breed a male a lot more times than you can breed a female. So it's very important to have a high quality male. Now, the advantage of starting off with a female is if you can get you a really good female, now all you have to do to get a great male is pay a stud fee. You don't even have to get the dog. You just have to pay a stud fee, because a lot of really great males won't be for sale. So you might not be able to get a great male, but you can still breed to a great male.
That's right. Yeah. Yeah. That's
So
why I like females first.
that's the
Yeah.
advantage of starting with a female. All right, looking at this pedigree, we got Bolio again, and here we have Princess. All right, then we got Bolio over Goldie. Let's look at Goldie and see what Goldie's out of. Some Klaus blood. All right, so he did use some Klaus blood. Let's see. I thought I saw. Okay, so here's our hope. That's going to be your tombstone stuff. So let's see what tombstone was bred to be. I don't know this catfish dog. I'm wondering if it's a tater. No, it's not Tater Faith, because it would say Patrick's if it's going to be Tater Faith. But let's see what it is. Maloney's Toot. That's the behind tombstone.
Right.
All right, so we have Crenshaw's Brook. So anyway, my point here is you're still seeing Bolio bred back to his daughter. This is Red Baby. So he took a 3/4 and bred it back to a Bolio. So this one's not 3/4. So the top that's 3/4, but this is 50%. So that's going to make this one 62.5% Bolio. And then down here we have Bolio Tombstone, Bolio. So this is 50% Bolio. This is 50% Bolio. So this is 50%. So you take a 50% Bolio dog to a 62.5, and you're going to be at 50. This dog here, Hungry Eyes, is going to be about 56% Bolio. That's going to be its coefficient of relationship to Bolio. That's not coefficient of inbreeding. That's coefficient of relationship.
Relationship. Okay.
No, it's also called relationship coefficient.
Okay.
COR and RC is the same thing. Coefficient of relationship or relationship coefficient is the same thing. COI is coefficient of inbreeding. Now, this dog is going to have a high COI because of the coefficiency of inbreeding on Bolio, but it's not going to be too high because the percentages dropped when he used Goldie and he used Hope. And Faith. There's your Faith dog. Okay, that I was talking about, the Tater Faith dog. So Faith was bred to a dog named Tater. If we look at offspring, we'll see Faith over here. That's the bitch. But then you're going to see Patrick's Tater. That was the dog that produced a lot of famous dogs. Tuffy was one of the famous ones. So Patrick's Tuffy was out of Tater and Faith. So Tuffy, I guarantee you, some of his daughters would have been. Oh, that is a daughter. Would have been bred to. That is a female. Would have been bred to Bolio. Let's look and see there. See, bred to Bolio.
Yep. Okay.
Because Bolio was that once. I should have known Tuffy was a female. She was famous.
Yeah. Wow. Okay.
Yep.
Yeah.
So we've covered a lot of stuff. What you have any other questions, or is that it? I know
Uh,
we can talk about some pedigrees and
m-
whatnot.
well, no. They had a lot of questions in the chat, but you was knocking them out
You
as
know
you.
that pedigree right there, that's your formula that you're going to see some from some of these guys that are breeding. The thing is that they never mention is the performance testing. They might say selecting for traits, but a lot of people think when they hear selecting for traits, they think you're talking about what color the dog is, or do I
Yeah,
like the
yeah,
dog, or does
yeah.
the dog bark behind a fence or on a chain? I mean,
Right.
come on, these are not selecting for traits. Selecting for traits means performance test.
Right. Yeah. You're right. Uh, and I kind of advise people, man, especially if you knew the new guys, the ones you be hitting me up asking me questions. If you can get out to some of these guys' yards, and that's what we need, more yard tours. That's
Yeah,
what.
you need yard tours, but you also yard tours don't show the performance testing. Go on a hog hunt if you can. Learn how
That's
to
right.
hog hunt if you
Yeah.
can.
Right.
Run your dog on a treadmill. I want to get a couple of treadmills. We had a treadmill years and years ago,
Yeah.
but at one time I sold it because at one time owning a treadmill was considered to be dogfighting paraphernalia. Now, obviously, I'm not a dogfighter.
Right.
So when they started saying that was dogfighting paraphernalia, I got rid of it. I didn't want nothing to do with it because I'm not
Right.
going to have my dogs taken like Pat Patrick. I got too much in it. But um, but now that Schutzen trainers, or excuse me, IGP, um, they changed the name of it. You got IPO, IGP, and Schutzen. Same thing basically. There's a little bit different in routines, but it's basically the same thing. PSA, police dogs, military dogs, therapy dogs, veterinarians. Um, Agility trainers, dog competitions are having treadmill races. Treadmills is now today in the year 2024 are no longer taboo like they were in
Right.
2005.
Yeah.
So
Yeah.
I
You're
would like to get a treadmill again. I just don't have the room for one right now. But when we build that facility, we're going to be grabbing a couple of treadmills.
Yeah, yeah, for real. Yeah, yeah, yeah. You're right. Those meals and things, but now, they are used for to keep dogs in shape.
Yeah, we used to run a lot dogs with when we'd be running the four wheeler or something.
Yeah,
But the community's grown up. You can't do that anymore.
yeah, yeah, yeah. It's not ideal.
Well,
Well,
that's when I had a lot more access to land.
right.
Uh,
How many
can't do
acres
that
you own
anymore.
now?
I got 9, but across the street there was a 2,800 acre hunting club. Well, that's no longer the case. It's been sold and people live there now. So
Oh man, yeah, yeah. I thought I was doing bad. I'm sitting over on 2 acres.
that's good.
Yeah, yeah, yeah. It's all right. Yeah, I got enough room to do what I need to do, but I ain't got no neighbors right up on me. They a
Yep.
little bit up the way, but can't nobody build behind me, side of
Yeah.
me. I'm good. Yeah.
So you said
So
we were knocking out the questions that were coming in. That's good.
yeah, yeah, yeah. They said great interview, and I have had what he said. I have a great bred Patrick bred dog through Milkman Bond, the Undertaker. Yeah, I think we good, Lee. I think we covered it all, and it's a pretty long podcast, but I think it's gonna be a classic study material for
Yeah.
sure.
I want to say thanks to everybody that watched and breaking this into. Look, I don't really do the short thing. I'm gonna let you have all the shorts. So have at it.
Okay, yeah, 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 yeah. I just use the shorts to drive them right back to the big video. Oh, that's
Yeah,
what they do.
that's something I need to up my game on. But
Yeah, but man, it's a headache.
well, it's not just a headache, but it's
Yeah,
also a priority. You know,
yeah,
you have to. It's not top priority for me. I
yeah,
want to do it someday, but right now I'm still
yeah.
dealing in Christ. I don't know if you've ever seen the 4 quadrants of highly effective, the book Highly Effective People. I'm
Mhm.
still dealing with the urgent, and
Oh yeah,
after I get done with the urgent, then we'll deal with the planning phase.
there we go, there we go. All right, well, Lee, as
Agreed.
always, it was great talking to you.
Great
And
talking to you.
yes, sir,
It's
yes,
always nice talking to you. You're a real gentleman, and you have an excellent podcast. I wish you the best of success.
likewise, likewise, likewise. All right, guys, we out of here. See y'all next time. Go check out Lee's channel. everybody. All right.
Thank you for the show. You have a
Okay.
blessed night.